Oh, we are live, and I, since I did that, did not set up what I wanted to set up. How do I do this? Channel, there we go. Yes, I am definitely organized. Okay. Come on, load. Was offline 22 seconds ago. What the heck? You really gotta do me like this. Okay, don't music click and stop for a second. What's going on? Infinite recursion. It says live, no viewers yet. Sure. Oh, it's good now. Okay. You know what's happening. Yay. Okay, that looks good. That looks really good. Okay, awesome. So it should be fine. We can skip that. This doesn't seem connected. Who knows? This is actually connected up. It is. I'm going to presume it's fine. Who knows? Okay, let's begin. So last time we talked about a compiler, and we kind of started to write something that was similar to what we wanted. Yeah, this was it. Yes, yeah, we had DAP core, and I sat down yesterday night and wrote up a simple grammar that basically is going to be what we're doing today as well as what we did yesterday. I also cleaned up some of the code, and so we're going to be going through that. So effectively, we'll talk about the grammar in a bit, but the grammar is structured pretty much the same as it was structured the other day. In terms of the fact that we have letters, letters, digits, and signs, followed by a sequence of digits for our numbers, identifiers, our letters, underscores, and so on. So our ABNF is structured here, and I'll talk about this a bit later on once we start passing. But for now, it can just stay as it is. And the cleanup was actually quite nice. Just some formatting things, but the main things is past number functions are a lot simpler now. It fits on one screen, which is always kind of a big thing for me. I always like my code fitting on one screen. For functions, it doesn't necessarily have to be however many lines. This is only 40. It doesn't necessarily have to always do that, but yeah, it's quite nice when it does. You can be that, and a little bit softer. I don't know. But yeah, so it's very annoying with the voice in the background. Let's see if we can skip that. I couldn't adjust any songs. Do you really be telling me that there's non-songs that? Okay, sure. Let's just do, I don't know. There's so much to choose from. I don't know, man. Just chill music is fine. I don't know what the heck that is, but sure, let's go for it. Yeah, sure. Okay, so effectively, the idea comes down to this, is that we have this, we talked about hints last time, right? So we're going to start off with a hint of integer, and then what we're going to do is we can go, okay, let's see if the first character is a full stop. If it is, then we're going to pass the digits after the full stop, and this pass digits function takes in a parameter that sees whether or not it's allowed to be empty, right? And so at the end of that, if this throws an error, we propagate the error. Otherwise, we add it to our raw buffer, and then we set that hint to floating point. We do the same thing. We can't do a very similar thing if it is a digit. If start's a digit, then what we're going to do is we're going to add on to start the rest of the digits, right? Up until basically the full stop, right? And this all coalesces into this really, really nice macro function. This macro function basically is going to be kind of the gist of what most of the code kind of will become for a lot of the parsing and stuff, is kind of using these macros to make the code a little nicer. And we can have a look at what this macro function does. And so the first thing it does is it has a basically they're kind of almost, I guess we could say, like an implementation layer and a kind of interfacing layer. So you say, okay, I want to try consume something. You have to give us self, because we need, something to operate on. And then you give us a sequence of tokens that you're going to allow to be consumed, right? So in this case, I shouldn't say tokens, I should say characters or symbols or whatever you want to say. And so in this case, we're saying, okay, we want to try and consume a full stop. Or we can also say try and consume a E or an E, right? And what will happen is it will return either some or none, depending whether or not it could consume that. So it will go and will try to consume the member, and it uses the implementation function here. And if this succeeds, right, this condition succeeds, it will consume the character, right? Otherwise, it will map to none. So actually it's quite clean. It kind of grabs this like double if statement that was really ugly before. Like very, very ugly, I didn't like it. And it kind of allows us to kind of grab that really ugly if statement and merge it into something that's a lot nicer. Okay. And so the implementation is actually pretty straightforward. So the first step is, hey, if you give us nothing, it's false, right? We're never going to consume nothing, right? Maybe they're saying that we want to support later on, but not saying I want to support now. Otherwise, if you give us something to consume, as you can see here, what we're going to do is we're going to take that something that you asked us to consume, and we're going to say, hey, if the current character equals that item, then we're good. And we're going to chain these along by using this OR. So this is a recursive macro. So basically each of these cores will call itself. And so this one here is going to do this core here. This is basically going to replace this with, like, for example, C equals plus, and then it's going to do an OR, and then it's going to repeat the whole process again and grab the next character and go C equals minus, OR, and so on. And then the very end will be all false, right? And so the all false is just the way that we can very easily handle it, so that we kind of have this finishing point, right? And we don't need to worry too much about the chain. Okay. Ooh, very fancy. So I'm just like, there's so many different things. Okay. Interesting. There's so many crazy new tools. Anyway, so that's the rough idea. You have this try consume pattern over and over again, and it's pretty nice. Okay, so Twitch has gone really crazy. Yes, let's break this down a bit more. So what are we trying to accomplish with this? Well, we're trying to be able to like write mainly this stuff much nicer. So before we kind of had to write that manually, so you've got some very complicated statements. In this case, we can just try to grab it, and if so, we can push it, right? So this is an optional plus or minus. This is a required E or E. If you require this, then you have to do this logic, right? And so the code becomes a lot nicer. Just overall, it's about reducing the size of it, Anyway, okay. And it's really cool. Man, all these new changes. Wild. Okay, anyway, so that's pretty cool. Let's go into kind of do the next step. So our next step, which is the very easy step for today, is trying to figure out how to pass a string. So when we talk about passing a string, let's add the first line of code that we'll need, which is basically, hey, we have a string. So if you get us a string, then we want to pass a string, right? Now, we don't really have to give C in this case, because we already know what it's always going to be, right? There's not much point doing that. This is going to take a mutable reference to itself, and it's going to return, again, a token type, or a Lex error. Okay, so that's pretty nice. Let's break this down. So, okay, how do strings pass? Well, if we do just a very simple approach, it's basically just going to loop forever into a buffer. Sure. Right, it's just going to be, I guess, this? Yeah, sure. And then it's just going to basically go, yep, okay, at the end, the buffer's good. Your token type is going to be a string. Do I even have a string? I do not have a string. Let's add a token type for string. And this is just going to take in a string. We'll probably want to do more later. But anyway, so we have a string, and this is going to take in our buff. There we go. So that's good. Now obviously we're not reaching this statement, but we'll want to kind of have some condition. So we're going to end up matching it. That's a bit loud. And the way we're going to match is pretty simple. We're going to say, okay, let's match the current character just as we normally do. And the interesting thing about strings is that we're actually always going to consume it. So we might as well just say self.chars.next, right? There's no point doing anything crazy if like peeking and stuff, right? We always basically want to consume it. Okay, so the first one is pretty easy. Hey, if you give us a, parentheses, or not parentheses, quotation mark, then we're good, we're done, right? So this can just be finished. And this can just basically say break. And technically I could actually even just say break token type string buff, right? We're probably going to come back and rewrite some of this, so I don't necessarily know how much I want to write it. That's pretty good. Next step would be, okay, if we ran into nothing, this is an issue, right? We're basically saying, hey, we have an error. But the issue is actually more related to the fact that we're missing an expected symbol, right? So our expected symbol was a token type. It was a character technically. I don't know, the missing expected symbol thing, I don't really like. I'm actually going to change that right now. Oh jeez, it's a fly. Let's change it. So this is actually going to become a character rather than a token type. Well, that's not true. The problem is it's a character or EOF. You know, let's go. Let's go and just go string, and then we can just say EOF as a string. Rather than worrying about it too much. This is going to break a bit of code. So the first one is this here. But see here we have this like weird thing where you give it like a weird numeric hint and so on. This was like annoying. So here we can just say like, we expected a digit. So you can just say like a digit here. Or, 0 to 9. Right? Well, I mean, I probably wouldn't say that it needs to be a string. That's probably a bit ridiculous. Sure, you can just be a string. But the problem is that we need a lifetime here. But the lifetime's fine. We can bind the lifetime to this. And that should be fine. Yeah, like the thing about the lifetimes that's really convenient is that you don't necessarily have to, what the heck did I just do? You don't have to, like, change a bunch of code once you add lifetime. Only the code that relies on the creation of that. So even like stuff like some of these ones here could probably change. Like unknown symbols could probably be not as necessarily a string. I mean, we're probably not going to use unknown symbol. Who knows? Anyway, what am I looking at? My God. Here we go. Okay, so we expected 0 to 9 and we found EOF. Wonderful. And the same thing down here. Here we expected literally this, but we found EOF. That actually works really nice, because your found token is, you can't really like expect EOF, I guess. So I guess that makes sense. Okay, and now it's going to complain. Okay, so we've covered some, we've covered none. What about like when it's just a random character? Well, let's do that now. So sum of C, we're just going to add it. That's it. There's nothing crazy. Now, I'm sure those who are a bit more observant will notice that this won't work with everything. Like we need to look at escaping and stuff, escaping strings. We can do that very easily. So we will cover that in a second. This is a weird pattern that I'm finding myself writing a lot right now. I don't necessarily hate this pattern. I just think it's a bit weird. It kind of makes me wish there was kind of some kind of like loop match where you can kind of like grab this behavior and break it up and then like make it a bit more explicit. Like something like this. We could even just write it in a single line. Like this. I feel like that would be like a nicer way of writing this stuff. I don't really want my macro to do that because I feel like that's a bit extreme. I don't know, man. It's just probably me writing more of a functional style. in a language that's probably more I don't know. This is still pretty functional. Who knows, man? Okay, so we're building a compiler in Rust. That is good. We're vibing. Okay, so what's the next step? Well, the next step for me is I don't know, man. Probably add escaping. Sure. I mean, we probably should check it works first, though. Did I really break this? Can I borrow it musically more than once? I remember this being an issue at one point, but I don't think I broke it. I literally did basically nothing there. Okay, the only way we're really going to debug this is by doing a cargo build. Okay. So, pass number is 1. First mutable borrow happens here inside a macro. But it should be fine. The reason this should be fine is because, I mean, 1, we haven't changed anything. But that error. We do change this. I'm wondering if it's binding to the same lifetime as the Alexa. In which case, what we could always say... We've got too many files open. We could always be like, okay, you go give us a static lifetime. That's like valid. It may just be binding to the same lifetime as Alexa. It was. Okay, that makes sense. So what was happening is it was going, okay, hey, the lifetime of... It's kind of inconvenient, but it was saying, hey, the lifetime of this like return value here, right? Because it can return a Alexa error, and because this Alexa error can be bound by the lifetime of the caller, it basically ended up trying to like consume it twice. I don't know. I'm sure there's a better way of writing that. I'm not fussed, however. Okay. I think I'm pretty happy with that. Let's just try to pass a string first before we go much further. But before we do that, let's also actually remove this and make it read from a file, just because that's a little bit more convenient, right? And then we can start writing tests for it. And then we can basically write all our cases in tests rather than have to rewrite our tests later on. So the easiest way of doing this is probably just to grab a file reference. So use, std file, or what is it, IO, and then file, I think. Okay, where is it? FS, of course. I can't just create it with a string, right? No, I can create it with a string. Because path P must just be like a reference of a path, and so it must be valid. Okay. So I need command line arguments, which means I probably want to build clap. We'll chuck clap into this whole system. So let's do that now. Make sure it's in the outer one. Here's our clap. Let's just grab clap and bring it in here. So clap is basically just a command line library. It's very, very convenient for a lot of reasons. So now we can grab this and we can say, okay, yep, we want to have clap and we want to have app and probably our, is it command? It's something like that. It's not command. Sub command, there we go. So what we're going to do is we're going to have a, my memory is pretty decent for like 20 years ago. Not 20, but a little while ago. I don't really remember. I think it's like, it's something, sure, X. And then you go like, okay, new, sure. Go give us a name, DAP. Well, technically Dapper is what we're going to call it, compiler. We need like a hat logo. The version, let's be very nice to ourselves and call it 0.1. I wouldn't really say this is 0.1, but sure. And we'll chuck ourselves down as the contributor. And then we'll chuck an about page and we'll go, okay, this is a very cool compiler. Yo. Anyway, I think, so yeah, subcommand, okay, cool. I don't know how to go to subcommand. How do I do one? From YAML or with name? With the name. We'll call it debug, because we don't really probably have a build, and it's args from usage, or is it build? I don't know, okay. Oh god. Args from usage. Then we give it a string. I think I can just do like this, and then put this over multiple lines, right? I can, look at that. I do like that feature. There. Then I don't remember how to finish it. Oh. Oh my god, there's so many. What's the difference? Oh, okay. Sure, it's fine. Honestly, I think it's fine to do it this way. So the first thing we want to do is we want to have like a show step, right? So you can say like show, and then you can like show us values, right? But we also need input, right? So input, which is the file to load. But you also have to like have the ability to show multiple values. I don't really know how to do this though. Let's have a look at the information. Ah, yes, I love this website. What the heck is this? I'm sorry, what? Yeah, okay, great, wonderful. Thank you for having a broken website. MetaLife. Shouldn't be that hard. Args from usage is what I'm really looking for. Maybe that's better? I don't really know if I would say that that looks cleaner. Like, does that really look cleaner? Um, I really don't think that looks cleaner. I guess what I'm going to do is just say show, and then now to specify multiple values, I think. Well, okay, so the thing is that you're going to say debug, and then you're going to have like multiple, you can have like subcommands on that. But right now we're just going to say run debug, and then basically, I mean, you could even have like tokens and like show all the tokens. But I prefer if it was like show equals tokens, like strings, I don't know, whatever. Let's just do it this way. Maybe. I feel like that's not how you do it. This comes back to me. Nope. What? He's like subcommand? What? Subcommand matched? Oh, you can. Look at that. That's what I'm looking for. So what you would say like debug followed by some submatches? Some decent music actually. I don't know if you put the less than greater than around it. I have to unwrap it. Like the file name has to exist, right? So I think it's like open. Maybe it's like a is read. Oh, read to string. I even need a file now. Deacons fail. Yep. I think I just have to make my main function return result. What would be the default value for result though? I guess I could just say like that. And the error would be, I don't know, Is there a result type in here? There is a result type. Okay, I'm just gonna do that then. It's a bit weird though. I think it's a bit weird that I have to like do it this way, but it's fine. I probably should create like a result type that wraps it, but it's fine. And then we just have to create Alexa. Like this. Right? And then we're done. I mean, basically, yeah. Now what we could do is we could be able to clone the Alexa. That way that we can do things with the tokens. So let's do that. We could create a new Alexa, but I think cloning it just makes more sense, right? Can I do this? I do want derive debug though. And clone. Oops. I can do that. Does that work? It looks like it does. Okay. If I don't know, I think you have to say like, I don't really know how you would do like values of. Oh, that's how. Weird. Okay. Default value. I don't know what default value is. I'm going to presume the default value for anything like this is going to be like an empty array. It's much quieter today. Sad face. Okay. What do I want to do next? I don't know. I think I just want to like show a cool like GIF of this. Like not GIF, but like a cool like UI version. Like GTK open up like a window and they can like see the tokens. That'd be pretty cool, even if they like waste a couple hours. You know, you don't like. I want to go best level this stuff. I don't really care too much. Okay, so it shows it's gonna be a vector. Can I do like a contains? Nope. How do I do a contains in a vector? Let's see. Includes. Nope. Okay, vector contains. It's probably like find is what I would say. Yeah, there we go. So we're finding on a predicate. I mean, it's fine. It'd be nice to just say like find this specific string. That's not really what I want anyway. I guess I'm just gonna give it a predicate. And this is returning option, so let some, we don't really care what it returns. It's kind of weird, but sure. Okay. Is it like, I mean, I presume it's not going to do a copy when I dereference this. Let's see. Alright, I hope not. I probably should make these all constants, but I'm being a little lazy by not doing it, but I don't really think it's going to make too much of a difference in the short term. So you can see show equals tokens, for example, valid values, tokens, and AST is probably the two ones we're going to support right now. Okay, so if we can find and sum equal tokens, then we can put out the tokens. Yay! Okay, and in this case we can create a copy. And clone should exist. It just doesn't pop up as a help because it's like a derive. So it's like a compile time thing. So it means it doesn't exist up until this point. Also, if you're enjoying this, you can follow and you can see the cool new following animation. It's kind of cute. Anyway, because I was bored. What do I want to do? I don't know. Let's just for now, let's just print them out. Basically, just do this, and then we'll add the GTK thing in a second. So, okay, that should be fine. Break. We'll do like a print line. EOF. Breaking. Okay, and then this code goes away. Fair enough. Wait, why are we borrowing it immutably? Find requires immutable reference? That seems wrong. I'm sure I have to just take like an item over this, sorry. What's the type of shows? Clap values. There's no way. I'm not going to take a mutable reference of it just because I can. Oh, is this like an iterator? That's why it does. Okay. I should probably create a vector from it then. I think it's like probably like a dot collect method is what I want. That typically just returns a vector straight up. Oh, but I do have to actually specify a hey, I want a vector. Really, it's just going to be a vector strings, presumably, right? Okay, sure, strings. Okay, for goodness sake. What do I have inside my vector? I have capacity, sure. I thought I had a find method. Nope. Contains. Okay, let's just do it this way. Hell yeah, it was contained. I was just using a wrong structure. Nice. That's nice. I'm happy with that. That's very nice. Okay, let's try. Yeah, we don't need file. Fair enough. I mean, I feel like you should have to call A endpoint, but anyways, let's see. Oh, I probably have to do double dash and H like this, right? Yeah, there we go. So you can see. Yay, look at that. That's really cool. Yeah, okay. Oh, dash V for version, sure. Yeah, the version looks fine. I typically like a verbose mode as well. It's typically what I add. So it'd be like some kind of like arg. Like, okay, probably doesn't have to be that extreme, but like just this. Okay, just lowercase v and verbose, and then it would just be run with more information. Okay. Yeah, V or verbose. And typically there's like some kind of level that's associated with them. You know, give or take. Okay. Now I can run it for file. How do I make the... probably if I say debug, it probably will be nice enough to tell me. Yeah, I need a file. Awesome. Okay, so my file is going to be examples. Where is it? Hello world. And it's not going to do anything because I need to say show token. What? I mean, I presume it's opening the file. Oh, do I have to like say like equals tokens? I feel like this one here is like, quite annoying to run. Okay, and then if I use lowercase, I feel like it should tell me a bit more information. But yay, that works. Look at that. We have a bunch of unknown symbols that we don't know anything about, but yeah, we can match the braces, and the match the braces looks fine. We have a string that matches. We have an unknown symbol. So let's start off by adding these unknown symbols. So the first bit of symbol that we have is just some separation characters, right? So for example, we have the semicolon. This is just a punctuation. Yeah. And then the next thing is what happens when we have ASCII letters. This is going to be pretty easy. Basically just gonna kind of blurt it out. Okay, keep going until we basically reach a character that isn't alphanumeric. Or digit. Or underscore. And otherwise, we just stop. Hey! Just a message now. How are you going? Muyani. I think is that how I say it? How's everyone's day? Hopefully pretty good. Yeah. We're just gonna be finishing off some identifier parsing, and then we're gonna probably jump into some stuff around the testing macros. And some UI stuff today, because why not? Oh, I could give a radix 10. Vibing. I'm very bad at checking chat, I'm sorry. Anyway. Hey everyone, any people who are joining. Anyway, what am I looking for? Oh yeah, I'm zoned out. Sorry. Okay, so if it's nothing, then we're fine. We can also stop. You can. It's technically not probably a valid program, but that's more passing things. I'm just gonna stop. Otherwise, we're done, and we can just go break with an OK result of token type identifier of buff. Now, there's not really an error in this case. There's no real way for you to get an error of an identifier. Like maybe you could like do a character that's like straight up, but there's just no way. We're just gonna always break on it. It's fine. There probably is, but I don't really care about it right now. We'll cross that bridge when we get to it. Okay, pass ident. Okay, we got identify as passing. Look at that. The only problem with identify as passing is that we actually consume each token, which is incorrect. We have to peek it. Because obviously if we, otherwise we're going to skip over the braces here, and we get misbalanced symbols. That's easy enough to fix. Yeah, I just need to do this. And I need to push the consume token. I'm just gonna forcibly unwrap it, just because I know it exists, right? Is it like, there used to be like this to unwrap, right? Did they remove that? I remember. Clearly, at some point maybe. Who knows? It's fine. It's a bit weird to have an unwrap here. I don't like having unwraps in my code. I typically try to aim for like 0 unwraps, because they typically are an indication of a bug somewhere. And you can normally wrap the error type at least, and have a pretty nice error type, but who knows. Okay. This is actually decent vibey music. It has some kind of energy to it. And yay! Look at that. Wonderful. We have accomplished everything. I probably shouldn't say breaking. I should probably just say like stopping. Because it's not really a problem. It's just like, hey, yes, we've reached EOF. Right? Yeah. Okay. Yeah, let's use GDK. I have not used it before. Let's see how it goes. Shouldn't be too hard. I've used normal GDK, but just not the Rust version. It won't be particularly nice, but who knows. Prepare your system. Oh, is this gonna be too much work? It does seem like it's very complicated. It probably doesn't need to be this complicated. I don't know, maybe. Maybe it does. Okay. We got away from my terminal. And I think it did everything. Let's see. Even though I said it didn't, I think it just copied it badly. Okay, SH it. Maybe not. Do I have to clone it? I probably have to clone the entire repository. They do be a bit unclear. Let's just clone it and see what happens. Probably don't have my SSH key set up correctly for it. Because he really uses GitLab. Okay, it's doing something. It is on a M1 Max, so the biggest difficulty will be compiling on M1 Max. And then getting errors, but I presume these errors are going to be fine. Let's just presume everything's good and we'll see how it goes. Welcome to most of software development. Just presume it's not going to break everything. Anyway, okay. It actually worked, which is kind of surprising. Do I need this like special build tool? There's no GH build. I presume it's just something it's like this specific. I mean, who knows, man? It may just work. I feel like we probably don't need bootstrapping. I guess we'll see. Okay, or not. Let's see what it says. I probably just don't have 80k installed, which is a requirement here. Hopefully there's a bit more documentation than what they've got there. I don't need much, but just at least like a little bit. Don't really want to do that, but sure. Check if a widget is another widget. Oh, okay. Bit weird. Oh, okay, so Glade is just like if you want to use XML. I don't really want to use XML, so we were not going to do that. Yep, closures are fine. I'm probably going to get more luck just by looking at project examples than I am anywhere else, probably, I would say. Okay, see it worked. Oops, it worked. Okay, brew install GDK. I don't know what this is, but I will install anyway. So we're installed. This looks like a different error though, very clearly, so I would say it's better. Maybe again I can just say brew install GDK. libgdk is probably what I'm looking for. Okay, we apparently installed it. We did not. Just tell me the requirements. I love it. This is so extreme. It does seem like a lot of work to compile it. Which is making me go, is this worth it? We'll see. How much more time do I spend? That does look very simple. Oh, that was very simple. Okay. You know what? Life is not so crazy. Does this work? Now, the big challenge for us obviously will be that we don't want to spawn a window every time, because the user should be able to compile without GTK, but we'll look into what's called like conditional compilation later. Right now, we're just always going to spawn the window, just because it's simpler, and simpler is a little bit better right now. So we're just going to go simply into it, and then we can go from there. I would love some type ins though. Okay, I'm not going to get any. Oh, here we go. So it takes an application ID. Do we really have an application ID? I guess I could give one. There we go. There's your application ID. What is this, Java? Jeez Louise. You don't have GTK support. Now I do want to abstract the concept of GTK as well, because I think if someone wanted to add a different like front end, that's fine. Like put this on the web. Make every application a web application. Yeah, let's go. It's just slow the entire compiler down for no reason. Sounds good. It's kind of weird that it's a closure here. The reason why this is kind of awkward is because like we don't really have a closure, right? We want to spawn a window multiple times. Based upon the app. Okay, let's have a look at this. I presume there's some kind of documentation on the somewhere. This doesn't help. Like at all. Yeah. This is what I'm looking for. Let's just do this for a second. See what it looks like. See if we can get like a window spawning, and then from there we can go. Ah, yes, I love out of out of what am I thinking of? Like stuff that doesn't work. Okay, so once we have a message dialog, it looks like this, right? Why can't I call run on it? Ah, I see why. That's gonna be a problem. So the main problem here is the fact that it's OXX has its own notion of what main thread is. And that's just going to be a massive issue. It's just not going to work the way you want. It would just complicate things because what will happen, right, is you want to do a bunch of like threaded stuff for like, I don't know, other threads, stuff like parsing and so on, and doing that in the main thread is convenient. Doing the main thread is convenient. I guess it's not terrible right now if we stop the world to show the Alexa, and then you close the app and then that causes it to pass. I guess we can do that. It's not terrible for now. We'll have to use like signal handlers and stuff to send it across threads. And we probably will want to like basically define our own concept of a main thread. It doesn't actually matter what like quotation marks main thread you use. Like you can spawn a new thread, do all your work in that other thread, and like that's fine for performance. You're not really gonna notice anything by doing that. Yeah, I think it's fine. I think that'll be great. Yeah. You know what? Why not? Let's rock and roll. Okay, so all we have to do is we'll just spawn that up and then block it, and then later on we can just spawn a new main thread, do our work with that new main thread, and then just transfer all the changes across. Okay, Easy. Okay. Let's go. Yeah, why not? We'll spawn up a new application for each one now. It's a bit weird, but it's fine for now. Is it just me that's finding this weird? Oh, do I need to add these for the preludes? Probably. Or I don't need to do this. Just like an empty this is fine. I'm just gonna call it Dapper. And then Dapper has this creation that looks good. We have flags, which we can add. If it actually tell me what flags I can add, it does not. Okay, I'm just going to presume the flags are fine. Okay, is service, is launcher, handles open, blah blah blah, non-unique, can override app ID, overlay replacement, replace. I don't know what any of those mean. We can figure that out later. Let's just see if this runs, to be honest. GDK critical, so at least it did it. App ID equals null, or application ID is valid. Oh my gosh, it did it. Look at that. PB vibing, look at that, that's nice. Okay. Hell yeah. I know there's a really nice macro, which is kind of what I'm getting into. But I can't find it right now. I remember there being like one that was like, hey, you can say GDK, then you can like specify like all the structure of the thing. Let's have a look at what someone else has done. They just create the labels manually. I mean, I guess I can just go like one by one. So the title is just going to say tokens. For the file name. Okay, so we have the tokens for this. That looks good. Everything looks nice. It's printing everything out. And all we're going to do is clone the Alexa and create unique tokens for each one. Really, I can't use immutable reference. But this isn't going to. That should be good. And then all we have to do is look at this. Yeah. It's not really what I want to look at. Hmm. Could I like clone it within here, I guess, maybe? I can, and then I can mutually reference this. That's kind of weird. It results in like a double clone. The clones are really cheap though, so I really won't worry about it. Should be fine. Okay, let's change the description to make it something a bit easier. Simple. And there we go. Slightly better description. I don't know, maybe that'll pick up people. Okay, so we have that. We have titles. Sure, okay, good. We got token types here. Let's just very simply push a new. I don't know. We want like a vertical display, right? GTK vertical. Like I want just a vertical list in GTK. Okay, let's have a look. A list box is probably what I'm looking for. I kind of want scrollable though. You create a vertical box and then you chuck in a scrolled window. Okay. And yeah, just build. Okay. Then I want to create a like an actual vertical box for all my nodes. Okay, apparently you can't do that for this. Let's have a look at GDK documentation on layout. There really isn't a lot of documentation on this stuff, which is always fun. Be nice to have like, this function does this thing. And not much else. Like, duh, 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 duh. Wow, there's a few ones here, but not that many. Somewhat similar to what I want. Not really, though. Yeah. I guess not really notebook either, honestly. It's very much unclear. I guess we're just gonna guess. Yeah. Natural, maybe? Like, there's literally no documentation on what any of these functions do. Insanity. Maybe I go look at, like, the layout. I see. So I can just create, like, a V box this way then. I don't know, we'll just say high as like 200. I don't know how to add it to the window. I think I need to do like a dot build actually. There. How did they add it? They did like this whole like UI GTK thing. I don't really know if I love that. It's very clunky, which is not a great thing, but it's fine. What I may do is just try to get the basic structure somewhere around what I want, and then not worry too much from that point. That's what I'm going to aim for. Okay. I think I literally can just say add on win. I can. No, I can't. Because I need this in scope. Yay. Okay. Label is probably what I want. I guess I just do an instant build on it. I don't know, set text. There you go. This actually may work. That's kind of weird though. They require a reference to text, but I can't promise the text is gonna live. Like why? Why do you require such a weird promise? Matches does not live long enough. Because text does not live long enough. Oh, probably because it's like rebinds it. I don't know. I'm just gonna go as label then, maybe. Nope, just straight up. No. Borrow value here does not live long enough. It's a string, so this text should last the entire program. Oh no, because we require it to last down here. That makes sense. That's very interesting, actually. That's actually very interesting. The problem obviously is that you're basically running into the borrow checker here, right? You have your Lexa that you're creating on that text, and then you have down here the fact that you're requiring this text to be cloned, which basically means that the references to exist inside of this move here, which is a bit interesting. Yeah. What we could actually do is make this whole thing an iterator. It's probably a bit too much work for not much gain. I think instead, if we just do like a collect function on it, then it's probably enough. I guess I would just like give you a vector of results. Then we're going to grab the next token. And if the next token is this, then we can stop. Otherwise, we're going to keep going. Okay, then it still obviously breaks, and the only thing that we have to do now is do a collect on it after we do a clone. Okay, then we get our tokens, then we can just say for talk. I can say for token, I don't need that. Okay, fair enough. Why do we require that this is borrowed forever? Like, that's what I'm confused at. Line 82 apparently drops it. Well, yeah, line 82 will drop it. I want to know why. I love how lack of help that is. Rust errors are great, except for when they don't help. So the problem with this error is it needs to indicate more. Like why it's not being dropped. So something is requiring this subcommand to exist. And I bet you it's the shows. So is it? Because even tokens isn't like there's no literal reference here. It definitely is due to this code, right? This code's requiring it to exist. But I wonder what part of it. I mean, you could always disable that, so that wouldn't have any tokens, and it still fails. I guess we could. Oh, this is maybe moving it somehow. The file name, that's it. The file name is being forced to live. Convert to a string. Yep, that's it. Suppose that first file name is forcing everything to live a bit longer than it should. So we just have to convert to a string, basically. Then move it. Move string into closure. This is a bit interesting. It's a bit more difficult than it seems because the problem with this is we're not really fighting too much with the borrow checker, but we are fighting a little bit with the borrow checker. And it comes down to the fact that we effectively want to use this file name so we can list a very nice like title for our thing. But to use this file name, it has to come from here. And we can't just grab it from here because this relies on submatches. So the toString fixes that submatch issue, right? It basically says, hey, we're going to take a copy of it so that it no longer relies on this to exist. But now it's going, well, okay, that's fine. But you can't just refer to it this way because we don't know when this file name is going to exist, right? So if we write like this, it goes, that's fine, but we need a reference. And I can't just borrow here, that's also incorrect. So it basically, interesting enough, comes down to probably two things. You could probably copy it again here, and then take a reference to it. But it's probably going to have the same issue. Yeah, it really isn't going to fix it. The problem is that basically this file name has to like be scoped to this, right? And adding two strings everywhere is not necessarily great. I think what you can do is you can force just one to be moved. So I think what we can do is we can, inside this scope, we can say let file equal file name dot toString. Right, we don't need to do the toString up here. Right, and then we can scope this file to here. And then it requires a borrow, we add a borrow. This will be grid crazy, so then we add a move. And then it's happy. Yeah, so that's it. So the idea of this is that basically what we're doing is we're taking a copy of it, just like what we did before, right? But we're actually scoping this copy to this. Which seems obscure, right? You go, how is it happy with that, but it wasn't happy with the other one? And it is happy with that, this will work. Let's just run it for a nice UI so we can actually see it. Though actually we won't have tokens, yeah, we'll add that code back in a second. But I believe the issue why it was, right, was even though we were copying it here, we were still relying on file name to exist, and this file name still relies on other stuff, for example, like submatches to exist. So basically it was inadvertently requiring this entire subcommand to exist the entire time. Or it was trying to copy the file name in here, right? It was one of those two things. It was thinking I had to do a copy or something else. Anyway, does it appear? It does, and we get the nice name and everything. Now if we show our tokens, we should be able to... It does compile. We are facing longer build times though. It looks a bit better. But yeah, they're all playing on top of each other, which is probably not good. We probably want to have some kind of better way of placing the boxes. So we do a V box here. Is there a way I can do some spacing in my V box? Let's see, add labels to layout. I probably need to give like GTK at least. And maybe even my Rust as well. Okay, yeah, sure. C++, but same issue. Pack start. I keep seeing this pack start thing, but it doesn't exist here. Okay, so I think it's like a Rust thing. Rust GTK builder pack. Or is this on something that happens in the build? Oh, what? So we pack them once we're all done? Interesting. Okay. So I guess once we've matched all the tokens, before we show anything, we gotta pack them. Now, this does exist in a different module. We just have to compile to see what one it exists in. But it doesn't tell us one. Okay, I'm pretty sure it exists in box.txt. Nope. Maybe not that like specific method. Oh, it's probably because it's a layout, and layout may not be a box. Yeah, so layout's not a box. So I guess maybe I want to add a box to the layout. Sure. Okay, why don't we call this layout? Not VBox. And then this can be a VBox, which is a natural box. I don't really know what I want to set for this. I'm just going to do this and then say layout.add VBox as a reference. And then here, this is VBox. Oh, it's still VBox to add. And the VBox.pack start. Oh my gosh, it works. Oh, so I don't add. I do VBox.pack end. And then I say pack this label. Expand, sure, fill, sure. Padding 20. What does this look like? It's better. Obviously, it's horizontal, not vertical, but it's better. I want also like discrete nodes, but I want to go simple with this stuff because I've never done most of this stuff before. This is the whole point. This is to try to show it how like you come up, how you like use things you've never done before. Because a lot of my job is walking into legacy systems that have not been touched in like 10 years and figuring out how they work, and so typically gain a unique appreciation for doing this from doing it. So I don't know, it's kind of interesting. The first step is always just trying to get something that works, but it's not so much about getting something that works badly, if that makes sense. You don't necessarily want to say that like just kind of it works, but it's like 4,000 lines of messy code, right? You see that all the time, you know, especially when people are writing assignments and stuff, right? I mark a lot of assignments, and the worst thing I can see is someone write like a 2000 line solution saying that's 400 lines. And it's just because they do like code vomit, right? You just keep writing code till it works, and then in the end, you've written like 8 times the amount of code that you needed. And the only way you can fix that is by basically changing your mindset. You're not so much about writing code, well, I find at least, you're not so much about writing code that works. It's more about writing code that is simple. So it's kind of like going, okay, instead of just like keep hacking till this works, let's just say ignore this, ignore this, ignore this, but only gonna focus on this. So rather than trying to like still incorporate all those components, but it just kind of works, but is broken in many places, you're physically ignoring those stuff that's too hard, and you're just gonna focus on the easy stuff, get that working, and then you can expand, right? If you know, at some later point. So some later point, you know, we'll probably use like a UI file and stuff like that, but there's no point doing that right now. And yeah, there was this really nice macro I saw. I would love to use that, but I would have to find what package it had and stuff and so on. Anyway, so I think I can just say packend and it'll do it, but the thing is that this box is doing it horizontally, which is not really what I want. I want to do it vertical. So I think I can do orientation. So it says dot set or orientation. Orientation, I probably need to import it. Orientation. I'm just going to import everything and then I will figure out what ones I need later. Vertical. Let's just do that. Import everything. It probably will kill our compile time, but you know what? It's fine. The one annoying thing I'm going to fix right now though is the fact that it doesn't show up immediately. Look, that's pretty nice. It does kind of do this like weird indentation thing though. Let's fix that. So that's the first step. It's basically probably like centering it, and so this centering is just wrong. Like you don't want to center this. You want to like left align it, right? So it's probably doing some kind of like alignment thing. Also, our scroll box is not working. What else? I would like boxes around them, and I want it to show up. Okay, so let's do the first thing where it pops up, because I think that's actually an option with the flags here. Okay, so if I go to flag options, what do we have? We have is service, is launcher, handles open, send environment, non-unique. You know, we're gonna ditch all of that and just Google it. So it's GDK, Rust, application, don't minimize on create. Maybe I want like a present or something, because sometimes that's what they call it. They call it like window.present. Nope. Nope. Okay. Okay, so so we have this like run function on our application, right? That's like the foundation of basically everything that we're doing is this run function. I'm wondering if we could have the run function make it show up. Okay, it's probably a good idea to have a look at these flags as well. That's fun. So we'll begin by looking at the flags. Though the flags don't seem to be helping. Let's have a look at these flags. So we have is service, is launcher. Don't try to become the primary instance. We don't want that. Not really what I want. Okay. Ignore that then. So we normally have a run function. Now, where's this run function coming from? Not from here. So it's probably from like application external or something. Is typically what they're kind of calling it, is having these kind of external things. So let's see. What else do we have under application? We have subclasses, we have GIO. Let's have a look there. That was pretty interesting before. Application class, application window, GTK application external. All this stuff could be ones that have what we want. That returns an application window. That's probably just us actually, so it's probably not too useful. Yeah, that is just us. Okay, but this has an add window. Awesome. Get window. Get Get menu bar. Inhibit. Is inhibited. Prefers app window. Remove. Set. Okay. But it doesn't have a run. So where's this running coming from? It comes from app extern manual. Interesting. Okay, why don't we just do this? GDK opens minimized. Simplify it. Not really what I want. Maybe I could just try. What does it look like? It really does just start minimized. It doesn't actually. I think it just starts unfocused. Maybe we can just call focus on it. That's what we want. Because it doesn't start minimized, it starts unfocused. Cool to fly. Sorry. Initial focus, look at that. Activates the current focus event. Oh, this is what I want. Very exciting. Render focus. Seems like quite a bit of work to do it that way. I don't really want to do it that way. Activate default. Activate focus. Let's try that. This may be on the window and not on the app. It is on the window. Hi. Hey, compiler addict. Or compiler. That's a nice name. How are you going today? I'm working on a compiler. I've been working on this for quite a while. But this is like the first time that I've sat down and written in like a language that isn't just like a bit of a kind of idea checking out. So I've got a bunch of like C++ projects where I check out specific concepts of this language, but this is the first time I sat down to actually write the full thing from start to finish. It's a bit of a different compiler. It's not really like a typical usual compiler that you'd find from something like C++ and stuff. It is a low-level compiler where we'll produce like, you know, bytecode, assembly, whatever. But the way it kind of is structured is very different. It's like a data-oriented language is kind of more what Star is for. And so it's very heavily transactional is the concept. So there's going to be some cool stuff around it about being able to like specify how data flows through the system very explicitly. And then you get like these crazy optimizations. Like I've run previous versions of this where I've just like looked at a very small section of the language, built just that. And it was able to like optimize rejects away and stuff like that. Which is very cool. Obviously, though, that stuff was very optimized and very specifically made just for that example. But yeah, the point being is now that we can make it more generally. Now that we've kind of done experimentations and other stuff. So you know, for example, it could take something that was. Do I have an example? I probably do. Let's go into here, and then do a copy. No, not work. projects, Dapper, which is the old compiler, which was starting to be written in Rust, but not really. Most of it's C++. Where's my examples? Samples, and then we have V1. I think this is the one I wanted. Sure. And then chuck this in here. So this was one of the examples that we had. And so you can define like various different craziness. But for example here, you know, I'm reading in from standard input. I'm then matching it to a regex or regex, however you want to say it. And then I'm able to handle errors explicitly like this. And the best part about it is I get this name and age out of it. But these are actually pretty well optimized. And so when you go and you try to, like, for example, we're adding hello world, space name, space age to print this out, you actually find that it will remove the allocations that get allocated here. And instead it will just change how it creates these and changes how it, like, grabs the regex and stuff. So basically it's able to, like, very well optimized kind of this kind of examples of code. It's pretty cool, and the way it does it is actually pretty simple. It allows you to basically write your own optimizations, if that makes sense. So you can kind of like specify, hey, in this specific case, when we're having data flowing from this place to this place, we can like skip it and change how it works. Yeah, it's really cool. It's kind of hard to explain without like showing how the assembly works. But one of the best things about it was this transactional view. So what you could do is you could create like a bunch of transactions. Do I have a transactional example? Maybe? I don't remember if I ever created one. Jobs. I do have a transactional example. Oh, look at that. So this was a transactional view. So you create a segment of data called a job, and then you give it in this case, this is actually a incrementing integer, so it's a unique integer, and you can have like where clauses and stuff, and these clauses like they're just invariant, so preconditions, postconditions, whatever you want to call them. In this case, it was unique. Half the stuff didn't actually compile, like unique didn't compile, just didn't do anything, just because there's no point in implementing half the stuff in the original one. It was really just focused. But, you know, adding specialization for that. In this case, we said, hey, just go and generate a next ID. And just that's all it needs to be. And so all you're saying is this every time this needs to get a new ID, it just goes and generates one. And this generate next ID was, I think, a function I had that was implemented that just was a I don't remember exactly how I did it. Oh, I did it here. I just set a global context for the ID, and I just created a unique generator, and I bound the generate next ID to that unique generator. So what this allowed me to do is say, okay, this thing could be like mutex locked, or it could be like a SQL identity column, or however you want to do it, right? So it gave you that flexibility. You also had like foreign, so like typically the way you wrote the data modules was very much like a database. That's actually how it kind of worked under the hood. It was basically like a database like in your code. Not really, but pretty close. Anyway, but yeah, there's a bunch of cool stuff with arrays and stuff. Like here I can say the size is length denoted, which is basically stating that the length is denoted as part of the array. But you can also say the array size is like unknown or whatever. And like I had a string example at one point, which was like you could say like, hey, I want to create a string. I can say like where string dot, for example, is like ASCII, and this would force the string to be like ASCII or UTF-8 or UTF-16. Right, so like these were like basically like interfaces, but they were purely kind of like compile time, and the way it passed in like virtual functions calls and stuff were very different, and so on. It had its own like ABI at one point, and so on. I don't know if we'll go that crazy with ABIs here. And so the point was that you could execute this job here, right? And this was actually a transaction. So what happened is it would grab all these transactions, pull them out of the function. And then they would get chucked outside of the function into this kind of main function here, into this transactional order. And then depending on how you asked it to execute the transactions, it could actually change how the code was executed. So the point being is that you could have like 50 functions that were nested, and it would grab all those transactions, pull them outside the functions, and then change how it calls those functions to like reorganize the transactions. So basically, the code that you were writing was very much not going to be the code that it was executing. it was very much just going to tear that code apart, but a lot of your functions would exist. It's just that they would be kind of specialized for how the transactions were going to be built for that input, right? So it's pretty cool because you could kind of like do this thing. So, for example, we could say non-blocking here, and it would actually be able to like execute them in different orders that were more efficient for the data that you were giving it, because we were stating that we didn't care what order they were implementing the transactions. So, for example, here, this is a pretty simple example, and we have two orders, two executions, right? So we have replace and merge. So replace is basically saying, here's like an array of items, and I want you to replace your arguments with those items, right? So you're just basically grabbing your current arguments, throwing out the window, grabbing some new arguments, and replacing it, right? Merge said, okay, I want you to do the same kind of thing, but I want you to like add it to the end, right? So merge kept the old values. So that's pretty cool. But the benefit of this is that the merge transaction, right, basically has to occur, right? We need to do the merge transaction, and we can't really defer. We can't do anything like this. This needs to occur at that point, right? But the replace transaction doesn't really matter, because we can defer this transaction whenever we want, because we can automatically commit the code, the actual action, at any point, because we already have the new array, and so all of our new transactions can base off that new array. But the actual committing operation, the actual modification, can occur whenever it wants to do it. Like, we don't care, right? Whereas with our merge commit here, we do care, because we have to create a new array, right? And even this could be optimized away and stuff like that. So this actual action here of moving the arguments to this doesn't have to occur yet. We can do that later. So we can defer it, right? And so what will happen is if you have a replace followed by a merge, it will actually grab the argument of the replace and push it into the argument of the merge. So you just get change the merge to just be a replace. So basically what happens is if you have a replace followed by a merge, it grabs this and basically just does this. Right? Now, the print lines will be correct, because it will actually change how the print lines work as well, and we'll basically just print this first segment here, and then we'll print the merge being the full thing. But the actual modification to your data just becomes a single commit. And so the big point of this is that a lot of optimizations these days focus on making code faster. This focuses on keeping your data being modified less, if that makes sense. So the point being is that you're basically reducing the amount of time that you're going back and forward between the RAM, right? That's kind of the whole gist of this. As well as, like, obviously doing up various other optimizations that typically are done. Yeah, exactly. It's basically just like having a database within your language. And the way you write code is very different. You don't really have allocators. You basically just tell it, hey, I want this memory, and it probably should be a malloc or like a heap allocation, right? Like we set these contexts here, kind of like J. So it's a bit similar to J in some ways. And you say, okay, like my hint is it should be heap, but however you want to do it is fine, and it will just choose the best way that it thinks. It's much faster than what you would think. Like, my examples often showed that it would beat C and C++ in specific cases. J is another language. It's made by a guy called Jonathan Blow. It's like a kind of, it's a very different language in some ways to this, but yeah. Like, it follows the same kind of concept of what you're focusing on, which is the underlying representation of the data, right? And it's not so much like, there's no object orientation here or anything like that. There's no classes or structs. You don't really need that. The way you handle is by using views. Views are basically like perceptions of a class, a snapshot of a class at a specific time and place, which effectively can encapsulate your data. As you can see here, this create function takes a task and returns some underlying data that is mapped to that based on whether or not it's anonymous or named. You know, it's based on the task itself, because the task could be like an anonymous task, it could be a named task. Anyway, but yeah, so it definitely actually ended up being faster than C in some examples by like 30 or 40%, which is incredible. And the main reason why is because it would just look at a bunch of code and just remove like 90% of it. Like at one point, it was really hard to test with some cases. It was really hard to test with like binary trees because I did like a binary tree version that would like be able to handle like those kind of like very recursive structures. And like any example I threw at it, it would just basically optimize the binary tree array into most cases just recursion that like had like a stack instead of actually having to like create the tree itself. Because it would be like, oh, you only need the tree, then you're calling a function on that tree. So the only way you could get it to work is by basically calling like a bunch of like searches on the tree, and in that case, it would have to actually create the tree. But if you did things like a count on the tree, or you did like inserts on the tree and stuff like that, and a bunch of other things, it would kind of just like inline the tree into the functions. Even if the tree was compiled, even if the tree was runtime generated, it could kind of like recognize that data dependency between the two. Anyway, but we are a little way off from there. At this point, just like building a cool looking UI. But the point being is that I've only been doing this like maybe 6-7 hours. It shouldn't be that long to get there. I should be able to get oh, didn't mean that. I should be able to get an emitter by the end of probably maybe next week. I'm very busy, so it depends. Anyway, getting this thing to show up though is going to be interesting. Even activate focus doesn't do it, which is interesting. Full screen, get application focus. GDK Rust. I did not compile it manually. I will probably do that this time though. I think the first one I'm going to do is compile it to MIPS because I know MIPS very well. I know x86, like I can read it, but I can't really write it. But I can write MIPS pretty well, so I'm probably going to make it just compile it manually to MIPS, and then we'll go LLVM to get some optimization. Because I'm not going to write like a lot of low-level optimizations. We will show how you can really nicely write optimizations using macros to basically act as like a DSL. I've got an idea for that, so we'll be able to do like people optimizations that way. For our own backend. GDK Rust window focus. But I think if you want any kind of serious performance, you do need LVM because they've got so many optimizations there. You just lose out on them if you don't have them. But it's so slow; it's not worth it for like the main one. I got a follower, I think. I don't know. I heard the noise. I did. Thank you, Compile Addict. I think did the cute little raccoon shop. Hopefully. Very excited. Definitely gonna stick around. Oh, that's sweet. I don't know how long I'm going to stay because I've got a full-time job and I'm in my last year of uni, so it's probably just going to be Saturdays and maybe Sundays. But who knows? I actually really enjoy it, and it's basically just entirely so I get motivated to actually work on it. Because otherwise, I will not work on it. I will do everything in my power to not work on it. It's the ADHD inside of me, of being distracted by every little thing. Like, for example, right now I'm getting massively distracted by getting this window to focus. I should probably just ignore it. It doesn't really matter, but it's probably fine. You know what? It's fine. I'm going to look at that later. Don't get distracted by small things. Okay, that's fine. And the text looks okay. It's not perfect, but it's enough that like I can build on it. I do want to fix the indentation, the alignment. I presume I can just say like label.align. Maybe under the new properties. Let's see here. Nope. Orientation. Nope. Label dot. Let me go here. Okay. Let's have a look at alignment. Oh, I can do that. That's nice. Huh. What does it implement? Set justify, there we go. And the justification here is going to be justification, which is going to be left. I bet you it's center by default, which is actually not a terrible default, to be honest. Left align is probably not a sensible default. That did not work. Why? So what's happening is like the size of this is only like this. But what could also be happening is the orientation of the V-box itself. If I don't expand it, what happens? Because what could be happening is it could be expanding it horizontally, which is why it's being pushed. So if I don't expand it, and maybe also don't fill it, it may actually fix it. I also don't want to use labels. I want to use something that's prettier. just like a little box. Nope. Okay. That's fun. So box builder. Let's see. Okay. Does this have a V align? It does have a V align, or a H align. It does have a H align. Align. Start. Let's try that. Does not seem to be aligning. That's fun. Could it also be the vertical box? Unlikely. Okay. And then let's have a look inside box, see what it's got. Yeah, I'm thinking of the H align. So maybe I could also set the H line on this. It's probably going to be set H line rather than... But that doesn't really make sense. The H line should be on the box itself. You know what could happen? Sometimes I misinterpret what these two ones mean. Sometimes like the vertical alignment is like the horizontal alignment visually. Nope, in this case it's not. Okay. Okay. The left side, yeah, that makes sense. Let's actually see if I can actually change this. So if I horizontally align them in the center, what happens? Let's see. Basically nothing. Very interesting. Weird. Oh, this does pack end. That's probably... Oh, that's fine. This will, because this will, if you pack start, it will invert them, so it'll be top. Error lens plugin. Oh, I don't know that much about it, so that's a great idea. Let me look at that. Error lens. This one? Oh, that's much nicer. Let's try that. And presumably if I make a bad mistake, that is infinitely nicer. Yeah. Thank you. That's gonna save time. Because I hate looking over it. Okay, box. It should be fine. It's set heterogeneous. Maybe I just don't care. Just keep moving on. I can look at this later. That should be fine. They shouldn't need to be homogeneous. Because, like, yeah, they should all have the same amount of space. Maybe, like, arguably that could be it, but I don't think so. Yeah, it's not. It's weird. It's like, they don't line up because it does make it seem like it's centered. Because if that's your center, right, these are definitely centered, right? But it's being magically centered. I mean, I could chuck a line here. And then a H line here. And then obviously change this, but this one didn't seem to make a difference. Unless these are somehow buggy and they're not actually setting it. Yeah, that's definitely something I'm going to change, is make it wider, but I don't think that's... Yeah, like, it's just like setting it to this. But I could actually change the width on the layout builder itself. Let's do this. Width and height, yeah. We'll actually make this a bit bigger too. And then win dots. I really wish there's like a focus, but there isn't. It's a bit weird. There must be a focus method I'm missing. It's fine though. The fun of documentation. No height. That makes sense. There's no width. That also makes some sense, but I thought there would be some width on this stuff. I guess the width is defined by the parent, which is the actual layout that they're inside of, which is okay. Yeah, so it has like set it, but they're still being centered. So there's like some magical justification that's happening here. What could be happening is like this set justify is somehow not doing anything. Like it's saying it to like read only or something behind the scenes. Like that isn't doing anything. I don't know. Typically justification is what you want. Label AST is always centered. Go away, fly. GDK. Get justification. I mean, I know the justifications can be set correctly. The X-line property, whatever the hell that means. Relative to each other. Oh. If you want to set this alignment of the label as a whole, use widget extension set h-align instead. Has no effect. Okay. Thank you. What, start? If this works, I will be slightly annoyed. Oh my god. Justification doesn't apply onto more than one line. Let's put a note here for my sanity. It works though. Therefore, we need to align it to the start instead. Thanks, JDK. I'm gonna just chuck this down and then we can do a find and replace for thanks JDK to, you know, F you JDK if it's not working at one point. And see how many times GTK, whatever the hell, screws us over. Now, my feeling here is that it's something with the application here is that what we could expect for getting it to work properly. Okay, so that's pretty nice. It's not like groundbreakingly good, but it's not bad to have the tokens show up here. And then, you know, I can at least see them, but it'd be nice to have them as like an expandable thing so you can like break them down and like search and like filter them and stuff. But it's fine. I think I'm going to just accept this and be like, this is okay. I do want like a headless mode as well, so I don't have to do that, but that's fine. We're just going to skip past that and we're going to write the actual parser. The way I write ASTs is typically quite different. So let's create a parser folder first before we do any of this stuff. Yes, that's what I wanted. And then we can create a mod inside this parser folder. Oh, there's some pretty cool macros, by the way, too. I'm using, that's a good point. I used to, so the first time I ever used Rust was probably about a year and a half to 2 years ago plus, and I used, at that time, Rust Analyzer, I think, maybe, to my memory, and it did not work. It was messy, and it was the main reason I stopped using Rust, basically completely, just because I could not get it to work. It was just messy. I believe right now, though, I'm using just the Rust one, which I believe is ROS, off the top of my head. Yeah. I believe it's using RLS now, which is much, much better. Yeah. Is it better now? Okay, you prefer it. Ooh. Is there much difference other than like performance speed and stuff? Or is like it's better analysis? Because the one annoying thing right now is that some of the errors are like you have to run it to actually see what the error is, because especially macro errors are very hard to tell what the error is actually coming from. Okay, I'll switch it over. I mean, between streams, I won't do it just directly now, but I'll switch it over and see how it goes. Um, I like both. The Rust Analyzer for me before was a mess, and even ROS. I think RLS wasn't out yet. I think it was like beta, and they just didn't work. They got a plugin now. Maybe I can just install the plugin. It's using useful practice, can't be considered stable. I mean, it's perfectly better than it was. Okay, let's see how this works. Sure. You can download your Rust Analyzer server. Yep, I will disable the other one. And then reload. Let's see. It's loading, and I'll let it compile, and then in a second or two, once it's loaded and checked my entire... Oh wow, that is definitely different. I love this type thing. Can I like do this? And that works. Ooh, that's very nice. Okay, this is like much better. Though it is a bit of a... The underscores are like destroying my brain right now. I will get used to them. But there's just so much on the screen, it's actually kind of hard to read it with all the underscores, yeah. I actually may disable that for now. Can I do this? Let's see. Settings, UI. And then extensions, RS. If it can't, it does not matter enough to me. I won't care. But like, for my sake of my extra arcs features. Oh my god, there's so many things. Semantic highlighting? Yeah, it is. I don't mind most of the semantic highlighting, because the semantic highlighting is typically pretty good, especially when it does this. This is nice, right? When it's able to semantic highlight this. Just the underscores, it's just like... I don't know. I think I'm used to it enough now. I don't know. I'll see how it goes. It's just like reading this, I just see underscores. It's like the code goes away. Yeah, it's not bad, actually. It's better than the other one, I would say. Though it'd be nice to be able to open like a reference to the Rust thing. I think that's one thing that most of them don't do, is the ability to just like click on it and open up the Rust reference for it. I think there is a way you can get that set up though, I'm sure. Yeah, I'll probably disable it later on if it's too annoying, but I don't mind this stuff here, so it's a bit obviously going to be depending on whether or not. You can't copy that. Interesting, I presume. That makes sense. Okay, so I'm never going to accidentally copy it if I do this. Yeah, okay. It's fine. Okay, we have a mod. That's fine, thank you for that. Okay, so we want our AST and just include our He's gonna give me the error until I include it. Sure. Yeah, I do ASTs differently. Okay, so there's like 3 different ways you can use AST, I think. Obviously, like it depends how you want to approach it, right? So the first way is how most people talk about it, which is a very, very tree-based format, right? And so tree-based formats is what I'm going to do, and I am going to do a binary tree, but it's about reducing down the heterogeneousness of the tree, which is basically the point where you have a node that can have multiple values, and you have to basically type check to see what value it is. It's just very inconvenient to do optimizations on it. So for example, if you have a program, right, you typically have your top level, right, which is your program. And then this breaks down into, you know, your decorations. So for example, like you have like, I don't know, let x equals 2, right? This could be a decoration, and this would break down into like a variable decor that is then, you know, for example, this would be non-const, so this would just be a constant one. Then you would have you know, your ID, which is x, and then you would have, you know, your 2, your constant value, right? Which I don't know why I wrote that on a curve. Anyway, so then you got these 3 things. So you have a constant type of a decoration, you know, it's not mutable or whatever. You have your ID, then you have your value that you're binding x to. And so the problem that can arise when you kind of do stuff like this is not so much in the let x case, but in the case of math. So for example, if you have 2 times 2 plus 4, the way you represent the tree is inversed, right? So your normal BODMAS rules looks like this, right? You have like 2 times 2, then you're plus 4. But the way you actually represent the EBNF, which is like kind of the specification for the language, is you actually do it the opposite way, because what you wanted to do is you wanted to match the stuff with lower precedence to the stuff that you want afterwards. So for example, this plus is a very low precedence, it has to be matched at the end. You want that to be matched after you do the times 2. So what you actually wanted to do is you wanted to pass it first. So you want the parser to come along and go, here's my sequence of my tokens, right? And I want to pass an add expression. So the first thing is I'm going to ask the parser to pass a multiplication expression, right? Which is then going to go and ask to pass a unary expression and so on. And you get all the way down until you finally find your constant 2. Right? And then this bubbles all the way back up to multiplication, which then bubbles all the way back down to find this multiply, and then does the exact same step to find the 2, and then repeats the same steps, but now pushes the plus all the way back up to add, which then goes all the way back down to get the 4, right? Yeah, which is perfectly fine, and is literally what I'm going to be doing in recursive descent parser. But the problem can come down to how you represent the structure for your recursive descent in your tree. So the worst way is kind of the intuitive way, which is that you have every layer, right? Now, most people don't do this, thank God, but it definitely does show up. And the concept is you would have add, which would have mult, right? Which would have, you know, your unary, and then also your constant, right? Now, this is a huge pain to deal with, because it basically means you have all these layers here that don't actually mean anything. Even though you visited them in the tree, they're not relevant to your input, which means that you never really have to match them. And so by kind of having these nodes, you basically have to have very kind of complicated transformations to see whether or not the left-hand side is a constant. You can't just check if it's a constant. You have to go all the way through the tree to eventually find the constant node, which means it's very expensive to go later on if you have very big, you know, kind of expressions, but it also means it's just much more complicated, right? You end up defining all these random functions just to traverse through the tree to find a specific node that you're looking for, right? Rather than just checking if the left-hand side of this add expression is a 2, right? In this case, it wouldn't be, it'd be a multiplication, but that's what you want, right? And so the first step is to basically flatten this. So in this case, for example, you would have an add expression, which would have the multiplication, but you flatten away the unary. So the unary would go away, and you would have, you know, 2, and you'd have times, and then you would have 2. And these 2 would also be nodes. These would be constant nodes, right? But still. And then you have add with like plus, and then you'd have 4, right? And this is perfectly fine. But the inconvenience comes from the fact that effectively this node here, yeah, exactly. But we don't know what the type of this is, right? From every fold call recursively. Yeah, but like you still need to build the tree, right? If it's not constant, right? You still need a structure. Like you're not necessarily evaluating it yet. You'd evaluate it later on. Or are you saying your value is multiplication, which is fine. You can do that. That's what this tree would look like, right? Where you skip the unary nodes. But the problem with representing it this way is that you don't actually know what the type of this is, right? So you end up having to check what the type is if you want to do any optimizations on it manually, or if you just want to do generic kind of operations on it. And so you end up with visitor patterns, which are just basically very hard to write well, that don't incorporate basically a bunch of state. So you end up having to pass a bunch of state around, which really isn't needed, but you basically just have to check what your parent has, you know, and it ends up being a lot more complicated to write transformations. And especially when you're writing very heavy transformations, which is really what transactions are, where transactions having to reach into a function definition and pull things out, and like actually be able to recognize and operate over an entire function, it becomes very, very complicated. So the first step is to simplify your expressions. And so the way I typically do this is actually, there's two ways. So the first way is you could represent as like a binary operation tree. And so basically this is a binop of plus with 4, right? And then you could even remove the concept of binary operator, so it just becomes an operator, right? And then this operator has like a subtype, which would be like binop and so on. But like it doesn't really matter, you could do that either way. And then you'd have like 4, and then this would be another operator, which would have 2 times 2, right? This doesn't actually fix it though, right? Because you're still doing the type check somewhere else. But the benefit is that the base type, the structure type is similar. So it means that it's a bit easier to do these type checks, but you could always just use an interface, right? So it doesn't really solve anything. So the second way is actually to kind of change from a tree structure when you're doing math expressions, which is really the only thing that requires the tree structure. Like at the end of the day, most other things don't really require it. It's just like a list of arguments. And you just change into basically a almost kind of like a stack-based approach. So what would happen is you'd represent this in the data structure as it'd be 2 to multiply 4 plus. So basically you represent it in Polish notation. And so these would be like separate nodes. And so what that means is, yeah, it literally reverse Polish notation. So it means that you have everything in the kind of format that you need. And you're basically only distinguishing between operators that operate on objects and objects themselves. And it's a little bit easier to deal with optimizations when you have math that way. I'll see how hard I go. I probably will begin with this. The main reason my Polish is nice, I typically don't do a full Polish. What I do is I break it down into the operator level. So operators is like a generic type that would then have the Polish inside of it. Which meant that like if you did it like a function call like this, and you had like 2 plus 2, and then you said like times another function call, right? Like you don't really want this to be Polish. It's a bit inconvenient. So this would have an operator that would sit above, and then on the left hand side would have the Polish operation here, and then on the right hand side would have the function call. So you can kind of do, you're kind of like making it still 2 types, but it's more convenient because like when you get down to this thing where you're using constants, it's much easier to resolve whether or not the constants are correct and stuff like that. I don't know. I guess it's just one of those things that we'll see. It's like I've done it before and it's worked out well, so I'm gonna believe like my history that it should be fine. But we're not gonna stress too much and just write a very simple AST at the beginning. Probably almost entirely enums. I don't know, program. And then let's chuck our grammar on the right hand side to make it easier. But it will not match our grammar, which is kind of important, I guess. You don't typically, when you match your grammar exactly 1-to-1, you're just gonna get weird stuff with it. Even program probably doesn't have to be an enum. It's probably be a struct. It's fine. So constants are pretty easy. I probably call it literal actually. I prefer the term literal. Int I'm just going to support I32s for now. We can come back and change that very easily later on. And floats will just support F64. Again, very easy to change this stuff later on, so getting it to work is more important for me right now. Canonicalization. Depends. I don't entirely know. Like, a lot of the stuff I like kind of keeping simple initially, and then I make things much more complicated. So I don't know. Haven't really thought about that yet. I probably would keep it generalized first though, before I go canonical. So not generalized, I mean look ahead, LL1. I'm probably gonna go LL1. Maybe LL2. I typically need just one look ahead. Sometimes I'll provide myself two if I want to make it easier. But I'm not gonna auto produce my parser. I'm gonna write my parser by hand. LR is fine. I just don't really see it. Like, parsing is the cheapest operation you can have in your compiler, without a doubt. Parsing it, like, you can write a pretty bad parser and it's still going to complete in like 200 milliseconds for the vast majority of inputs. So I very rarely find parsing to be the problem. And so for that reason, I will typically not care too much about optimizing my parser outside of making it pretty fast. Like, just the initial implementation is typically fine. So I probably won't make it LR. Anyways, we'll see. There's other things too, right? Oh, literal is Boolean. That reminds me, why don't we just chuck a bool in here, because it's easy in Alexa. Very lazy passport ID. Now I want probably... Are there any others? Oh no, I will have things like function will be a keyword. There'll be a few keywords. So I will create a pass keyword. Oh, definitely. I will publish on GitHub. No, don't throw that. Distracting is good. I just don't want to publish it when it's just Alexa, right? I think I'm going to publish it next week, is my current plan. And then people can watch as it grows. Probably next week. I am tracking it using Git. Like, how many changes have you made today? It gets a lot of insertions, but most of that's cargo. So ignoring cargo, it's not bad for a couple hours. You know what? I will probably commit after this. I should be committing more. Okay, yeah, I mean, I do kind of want to try pass. There's many ways you can do this, right? Where you're trying to like pass something. I don't like to go crazy with it. I probably am just gonna like do a point where you can go, like how much of the token have you passed, and then once it finishes, it will turn how much of it actually passed and how much of it's like it didn't pass from what point, so that you could turn that into like an ID or something, basically. So in that way, this means this will always basically return for the same reason that this effectively always returns, and I probably don't need to worry too much about this being crazy here. Like, this will always return. Oh, I just didn't save. Pass string. Where's pass identifier? Here we go. Oh, I didn't actually... Oh, I probably want to wrap this in an OK. Oh god. There we go. Parts boolean. This will return a string. Sure. And you can just return this for now. And then this needs to be wrapped in OK. This should be, this probably should return a token type. Actually. So this can be a token type. Identifier, which is just going to be this for now. Okay, sweet. Then we can actually write this. So the point of the whole point of like being able to optionally pass it is the fact that you can have like a fallback. So I think saying like pass bool or ID, I think we're just going to generalize it. What's the terminology I want? Terminal? Sure. Okay. Thank you. These errors aren't relevant right now. Okay, so all we want to do is just do our typical loop match thing. And there's no need for a start. This can just be a new string. And this is going to return a token type. Or really just a string, to be honest. Which will probably make boolean not a special type in our token tree. It probably just becomes actually just a terminal. There's another term for it I can never remember. It's like reserved. It's like basically reserved, but I don't know the name of it. What is it like? Symbol, but that's not really one thing of. Anyway, doesn't matter. This bloody fly. What the heck? Okay. Vibey. What am I doing? Alexa. Okay. Token type identifier. Sweet. So this becomes a terminal. And this needs a token type. Okay, so even these become the same thing. It's not really possible anymore, but it's fine. So we're just going to peek for each character, push onto the buff while it is a prefix of terminal, basically. Okay, so they have to be ASCII digits, sure. We won't use this for passing operators. Okay, we don't need this anymore. If it's an ASCII alphabet, can we put this over mobile lines? Or if it's digital, this, and it's the next token in terminal. We could also just do that as part of ident. Let's just do that. We're just going to tag identifiers. And then all we need is basically a set of token type matches, which can just be done as like a hash table, which means we need probably a static table, which is obviously a little bit more annoying in Rust than it is in other languages, because you have to do the whole lazy static thing, which is not necessarily that convenient, but that's fine. I probably don't have lazy static on this cargo. I don't know what version I need. You don't need to use lazy static, but it just makes it life easier. Do I need to use this here? I think I do. And then I can say like use lazy static. Everything. I probably will change these everythings later on, but for now it's fine. Chuck them after this. Yeah, you're right. I could do a match. I don't know. Maybe a match is better. How many keywords I'm gonna have? I'm gonna have actually not that many. My language really won't have that many keywords. Like even in a pretty big example like these ones here, most of this isn't keywords. There's defer, there's return, there's like elsewhere, guard, case. There's a lot of replication. And the performance of like looking them up each time is actually pretty minute. It's not really going to make a massive difference because most of the time the string match is going to fail on the first character. It's not actually going to have to go all the way through. And even still, like you're looking at 6 or 7 characters, right? It's not going to be the thing that changes your performance. In worst case, you can always change it later, right? So tag ident can just be a match. I actually like that better. Good suggestion. Okay, sweet. Okay, so not some. So false becomes a boolean. Honestly, they're all basically the same thing. I think instead I'm just going to be like this. If match, then token type, terminal, ident, else, token type, identifier, ident. And ditch the whole concept of token type here, and we're just gonna actually just like tag identifier this way. Yeah. And then the backup is just gonna be false. And I actually do want to consume the string here because I'm not just gonna pretend I'm wrapping around it. Okay, and then we can just say like something like, I don't know, false is true. It's annoying how like I don't really want to convert these all to strings. Can I just take a reference to them? Sometimes you can. Why is this thing? Yeah, it's because like this is like I probably can just do this. No, that's cheats. Yeah, I thought so. As ref, oh, that's good. But yeah, that's what I want. Yeah. The at thing. Oh, I could dereference it. Does dereferencing work on the string types? It does work. Thank you. Okay. I did not realize that. That's kind of weird though. I wouldn't expect it to work because strings really isn't up but like a kind of a pointer-like structure. But it's fine. Function, and also I will support if right now, and case, and where, and else. That's all I'll support right now. And I'll add the rest later. So these don't need to do this, and they just go pass identifier. And the pass identifier will be changed to be pass ident or term. Yep. And this also doesn't need to be mutable. I check mutable way too often. Oh. Ugh, okay. So it does a copy. Interesting. Yeah, so I knew about the strings being evacuate. No, not copy. But, oh, because it takes a slice. I didn't read this slice. I just saw from. And so I was like, oh, it's taking a string from the as pointer length. I was like, that does not sound good. A slice should be fine, though. It should be able to take that as reference. Which is why it's an as reference, I guess. That makes sense. Yeah, okay. I prefer the as ref here, though, to be honest. As ref reads a bit nicer than the this whole thing, because this reads as like, I guess it kind of makes sense. It just looks uglier to me. Honest. Though I don't mind the this is also fine. I have weird opinions, I think, sometimes about some of these things. I mainly coded in C++ for a very long time, so a lot of the Rust functions and stuff I do not know that well. Which is why it's nice to have you telling me, otherwise I would have had to look that up. Okay, identify in terminal, that's fine. And this is a little clunky, but it's fine. Like, it's going to be clunky because we're going to have to check what it is at the end anyway with this false, true, and function stuff. You end up going to have to just basically do string comparisons later on, which string comparisons are always not really the nice way of doing it. It's much nicer to like bind these as enums, and then you specifically choose the enum option that you want. But the problem with binding them as enums is you end up either with like 100 cases and this is like really ugly, or you end up having to use like a hash table to represent it. So when we go to hash table, we'll probably change that. For now, it's fine, I think. And also, like, Rust doesn't make it that ugly to do like matches on strings, even though it's not particularly great. And you can always like type def the strings, basically, do constant reference, constant whatever, ID, not IDs, constant fields, I guess, sure, to point at the strings. Okay. Good. What's that message? Is that important? These are the rough cases. Okay, vibing. Okay. So what do I want to do next? Probably, I kind of really want to get to types today. So let's just speed through this so we can actually do some type stuff. Because type inference, I typically use a Hinley Minley, whatever. It's a Hinley Minley? It's an E instead of L. I don't know. Type inference. It's something like that. Hinley Milner. There we go. This. I typically use this. It's like a Haskell type inference algorithm. But yeah, that's it. I change it though for Rust. Change it for the language though. You have to change a few changes. I think Rust uses a similar-ish thing. Most other inference algorithms aren't really that good. But best my knowledge is it does it. Don't remember. Yeah. There you go. Yeah, it's an interesting case. It is just unify. But it's actually more than just like, it's a bit more complicated than just unify, because the problems come down to the fact that Hinley Minley presumes that functions are single arguments, and it presumes that your kind of tuples, which is really your structures, are pretty straightforward and pretty simple and just are composed of members, and also are single arguments, right? And so Rust functions aren't single arguments, but it's pretty easy to change that into a single argument system anyway, or you can just unify each one by one from left to right, which is really what they do. But there are a few like rough edges that you have to treat specially because you aren't dealing with a pure language. And it basically comes down to the fact that when you have statements one after another, and Rust actually has this problem, it's actually not something that's fixed. And that's basically what that thing was saying before. And the problem comes down to the fact that it's too eager. So if you have something like this, right? Okay, thank you. Let me check in here. If you have something like this, you know, in my language it's like this, but in Rust it would just be like let x equals 2. And then you define like x equals 3.3. What's the type that it should choose here, right? And so a very eager system like Rust will choose an integer because it's the first type it sees, right? So it binds it. Now, technically, in the past, most of my ones will presume that this is a floating point, right? And the reason why it presumes it's a floating point is because this isn't actually an integer. What it is it's actually what's called like an integer-like. So it hasn't actually like bound it to an integer yet. It's just said it's an integer-like. And then this operation concretes it to be a floating point. Or it doesn't concrete it, it just makes it a floating point-like. And so you kind of get that inheritance. Because we don't know what the type, how big this integer should be, right? So making any presumptions about the size of the integer anyway is bad, right? I don't think Rust makes any presumptions about the size of the integer, but they do make about the type. Now, obviously, if you call a function, and this function returns an integer, we presume it's an integer, because that's a concrete type, right? So this really only matters for, like, when you have constants, right? And there's a few other rough edges as well, right? Yeah. I think a rough edge in most systems is the fact that you have issues around how traits and stuff have to be bound, I think. I remember that being reading up about something around how their type hits around it. I don't know if Rust chose it for a specific reason, but that could be true. Be explicit in your intent. I mean, it's fine. I don't think any either way matters. As you size everywhere. Yeah, that's true. You're not wrong. I mean, I don't mind for going upcasting and stuff. I typically I prefer the case of being explicit is good, where there's a case where something could go wrong, but in cases where the code itself doesn't have any chance of having like an undefined behavior, it's fine to not be as explicit. So like, for example, saying, you know, that x equals 2, then x equals 3.3, there's no real case for this to be undefined. The only case would be that this x is the wrong type and not what you're expecting. But as soon as you pass it into a function, like, the function's going to require a certain type, and so you're not really going to, like, get away with it, right? So in that case, that's why I don't think it matters too much. For the as you size thing, though, that definitely does typically matter, right? Because you're typically doing an upcast, which means that you're widening the string, the integer. And the widening operation, though, is typically fine, but if you're not widening, you're actually narrowing it, then you get problems. So, you know, for example, if you have like a, I don't know, let's say -1, right? And you obviously do this as a usize, that's a huge issue, right? And so cases like this, it's a problem. But, you know, Rust will let you call usize functions if the values are constant, even if this is like a, I think if you do something like this, it will still let you, I believe that's how you do constants of a specific type. I think it will be fine with that. I don't remember. Maybe it's not fine with it. Maybe you do have to say as usize anyway, even though you specify the constant is an i32. I don't know. But I feel like that should be fine. If it's very, if the code itself makes it explicit that it can't be negative, then you shouldn't necessarily need to bind it to be a usize. Which is effectively actually what my language did in a lot of cases, is that you could like bound things and say, okay, this thing has to be greater than this value or whatever. Like, that's just something that happens. And so in those cases, the casts become implicit because it doesn't matter. There's no undefined behavior that can happen, so casts are fine. And just make it easier to write code. But in cases where it's not obvious and where there could be negative values or where they could overflow and stuff like that, you would have issues. I think both ways are fine. I think Rust just takes a very kind of safe perspective. I'm a bit more dangerous probably with my safety around this stuff, but I think that's kind of fun. Alright, literal, that's fine. And then the next one is going to just basically be everything from the grammar. I don't remember the rest of the stuff. So we want public enum. What? Unary expression? Yeah, let's go upwards. Yes, exactly. Will I ever have more my atom? I will. I have function calls. Okay. Yeah, this is kind of what I was talking about before too, right? So that's S. And the snap emoji, whatever they call them. One of my favorite things of all time. It used to be like my it's like a fat raccoon like sitting in a chair and just like looking disappointed. It's solely the purpose of the name. I freaking love that. Okay. I hate this. It's fine though. We'll keep going. Okay. And then we want an operator. Yeah, I don't want to do it this way. I just want to do an operator. Okay. So we have the operator. And this can be a structure rather than an enum. And this becomes this. And probably a lowercase and public. And then our operator becomes, plus, minus, Boolean, logical negate. Multiply, subtract. Unary. I'll chuck unary in front of them, just to make it more explicit. I'm not actually in the US, so I'm in Australia. From new grad from second year diploma in software and development, looking for a job in .NET C#. Actually, my daily job is in C#. I do a bunch of other stuff like JavaScript and so on, but I typically don't like writing JavaScript, so I typically just work on the .NET stuff. But even being a backend engineer, it's still useful to know it and still useful to do it. Starting salary, it depends a lot. It depends upon like your past experience, I would say. I don't know. The problem with like salaries in tech is that they actually depend on where you live, not what country not what like country you live in, but like where you live. So, for example, if you live in San Francisco, right, where like prices are a lot higher to live, it'll be higher than if you live in Texas. You get paid more. Yeah. So yeah, and so Texas, you probably won't get paid that much, but your price of living is significantly less, so you end up taking more home, right? So it really comes down to like if you remove the amount of money that is like in rent and you remove that proportion of your salary, right, which is really the proportion that's changing. So you may be paid $40,000 more money from working in Silicon Valley, or even like much more than that, right? But like you're paying like an extra $60,000 rent per year, like it evens out, right? You're probably looking at somewhere around, I would say, you're at the beginning. If you remove rent from the equation, you're probably looking at 60K being a good amount, because rent is somewhere around, depending on where you live, $20,000 to $40,000 a year. For like, I don't know, depending on who you are. I would say that's probably a good range to begin at in a lot of places. Maybe less or maybe more. My rent is ridiculously expensive, but other people's rent I'm sure is less. So I'd probably say if you remove rent from the equation, probably 60 to 70 is probably a good range. That obviously you got to count food into that and other costs. A good starting salary in Australia, probably $80,000, maybe 90 is probably good. So we move about 20 to 30 from that, and then you never, even if you live in higher cost areas, you still don't get that much increase. But 80 to 90 is probably about what you're looking at. It also depends on your experience, right? You can definitely be paid. I would probably not say 50,000, but keep in mind Australia, the economy sucks, right? So like $80,000 Australian to Canadian, I think Canadian CAD is what? 75,000. So I mean, okay, it's not as much as I thought, but that you're still losing just like $5,000, right? So like the lower ground was, I said what, 60. I said 60k is like after taxes and stuff. But I mean, you could still be easily paid 70k. Yeah, so like it's not close, but it's definitely higher, but it's not. I don't know. It's only like 5,000. Is the Australian dollar doing much better nowadays? Like that feels crazy. Maybe it's just like the Canadian dollar is doing badly. USD, I meant. Oh yeah, the Canadian dollar is also not doing that great. That this is more of what I was expecting. Oop. Hey, hey, honestly, maybe your dollar's not doing so well, but at least you live in a country that is not an absolute like bloody meth lab, right? you, yeah. I'd probably rather to live in Canada than be sort to the US to keep it coming cute lower. Fair enough. I mean, yeah, it's probably better to keep it lower than it is to probably have a high if you sell a lot, but and it still kind of sucks from the perspective of buying things from America. But you know what? Oh well. But yeah, honestly, the signing salary changes a lot. But I think 50k. The thing though is like how many you've got 1 year of internship. That's quite a bit. I don't know. You could probably get a higher salary if depending on your skill level, depending on what you know, depending on what you're doing. You probably get like at least another 5 to 10,000. I'm very non-confrontation as a person, so I've always been very bad at negotiating salaries. Multiply, subtract, modulus. It does. It depends. Like the thing is, it's really hard to value people in tech because like what contribution you have vastly changes. So like for example, if you have someone who's very, very good at programming, let's say, is very, very fast, right? But they're very, very bad at documentation and they're very bad at like kind of helping other people learn, then you don't really have a great software engineer and it is not really going to be that useful to you as a company because effectively the downside of that is that you end up with a situation where you can't actually push their knowledge onto other people, but also no one really knows how any of their stuff works because they can't explain it. And also their code may just not work, right? Like everyone writes bugs, even if you're a genius. And so the fact that they can't write documentation on it means it's very hard to like get people to test it and stuff. Oh, people should do documents. I work at a startup and we have I was just going to open up my documentation and realize like all of our client names on there. And I'm like, yeah, some of those are under NDAs. I probably shouldn't do that on a public stream. But yeah, we have quite a few big clients. I mean, I can say some of our previous ones. Like, for example, we used to do the entirety of provide like we did a lot of customer experience stuff and employee experience stuff. We used to do it for what's it called? The Mart in America. Is it Walmart? Yeah, it's Walmart. We used to do it for the entirety of Walmart in China, which was like billions of like transactions a day. Or not billions, but it was like millions of transactions a day. Whether or not that be like surveys that were sent out or like responses or whatever else you got in the system, right? So there was a lot of like transfer just from that client specifically. We stopped only because they moved all their systems to the same thing and they decided to move it all to the American one because that was like the main system. Which kind of sucked, but oh well. But yeah, so we have massive ads of documentation. We have like entire like wikis and everything, and we're very much a startup. Ours was written in C#. We had some backend stuff written in C++, but I was the only one who knew C++, so I was the only one who could maintain that stuff. So we decided to move most of it across. It really doesn't matter. But performance is very rarely dependent upon the language you choose. Very rarely. Sometimes it does, literally. Like, I've had many cases where performance massively depends upon the language. You switch from Python to C++, you're going to see a big difference, right? But it also doesn't really matter if your code is decent at the end of the day, right? And C# has a lot of optimizations in this JIT, and you'll typically find that the performance would be pretty good. It does depend what you do. I believe that depends. Well, I mean, define what you mean by control the machine. Are you saying like how well you know the machine that you're running on? Because you're running on like a cloud service, you've got zero clue what the machine is. Other than like it's got virtual CPUs and probability is one of a set number of computers. Well, yeah, but like it depends. So like SIMD and stuff, that matters, and that will give you a huge performance upgrade. But like if you're doing web stuff, like you're never gonna get that. Yeah, yeah, exactly. You're never gonna beat that stuff. But if you're doing like web development, which we were doing a lot of it, you're never gonna hit your sims. You're never gonna hit your main. If you're doing any kind of service stuff, it's very hard to kind of get that cache-friendly best behavior and stuff outside of just trying to do it as best as you can, because it's so multi-threaded, or more. It's more like it's so asynchronous, right? That you just really are going to constantly validate your cache from so many people using your platform at once. It's very hard to kind of reach that like epitome of performance. So I would say it definitely depends what you're doing. But if you're doing anything like that, where you're doing like web stuff, it does not matter. Which is probably most startups nowadays are doing web kind of based stuff. It probably doesn't matter that much. Like even Dropbox changed to Python, which was a terrible decision. It's so slow, but like, that was because they changed their backend to Python, right? The actual server that serves all the requests and stuff, that could have been, probably not Python, but could have been something like C# and they wouldn't have noticed it. Don't know why they would change to Python. It's... Oh, yeah. Yeah. Video games, self-driving cars, planes, anything. Yeah. I mean, a lot of that stuff... you have to be careful too, right? Because if you write really low level stuff like assembly and stuff, or all the inline stuff, it's actually very hard to make it fast. Not so much because the stuff you're doing is hard, but because a lot of the time when you go that low level, there's a bunch of presumptions that can be made by the compiler that can ruin your day. Like I remember I spent about 2 months trying to optimize some code, right? It was some raw assembly that we had for a very old system. And like this was in the background, not mainly working on it, right? And I couldn't figure out a way to optimize it. We had done so many different things, maybe got like 5-10%. I added like a single NOP instruction, which does nothing, right? And it sped it up by 2 times. And it was literally just because we had a loop, right? And the loop was slightly too big to fit within a cache. And so it was kind of like folding over to the next cache. So by putting a NOP in the right position, you made the like separation in the cache a bit nicer, and so it meant that it could load and operate on one segment of data and then switch over to the other segment without like kind of stopping and starting between the two. So it was like kind of split up better. It was a few more than just one NOP instructions, but there's a few NOP instructions in places, and it just increased the way the data was loaded in the cache a whole lot nicer, because now suddenly your instruction cache wasn't so throttled, right? You actually could spread it out a bit more. And it's really only a thing for x86. If you're dealing with ARM machines, you don't really find that, because the instructions are all the same size. So typically, it's much easier to kind of ensure the instruction limits. But it's something that the compiler won't do, really. And like that was very hard, right? And so it's very easy to write bad assembly like that, where you write a bunch of assembly and you write, for example, too many instructions in loop or whatever, and your instruction cache is basically just constantly throttled for every iteration, and it isn't caching these kind of instructions, right? And you're not really going to find much performance with gate loss from that, but if it's a very hot loop, you can. But that was probably the best optimization I've ever done, was that. I mean, I've done a few other things. Like, you'll find that most of the big optimizations are like 1 or 2 lines. I've actually very rarely found a big optimization I've done that's written in JavaScript. Oh yeah, that's right, everything in JavaScript. The funny thing about that though is I don't know if you're kidding, purely based upon the current state of the web development. You know what? Screw Rust. Let's just write this compiler in JavaScript. Yeah. You write it in Node.js, and then everyone will be like, "Why does it take 8 hours to compile this code?" And it's like, well, it's just code is hard, right? It's really hard to compile code. Get away with it. Less than, greater than, Node OS. I did see that, and I honestly thought it was a joke for a very long time. I was like, oh, this is a funny joke, just like the fizz buzz in Java. I like writing these out, just because it makes my life a little easier if I can actually just read it. Even calling a function, by the way, is an operator. That's actually a very different change in this language I'm going to make. I don't know if it will work, but we'll see. HTML is greater than CSS. Man, SQL is hell. SQL is fine until you actually get into some heavy-duty SQL, like partitioning and sharding. And sharding is just like it's just shit. It's fine. It's just so manual. You end up having to define these extremely. Yeah, no, we never use that. We use Azure SQL or like Microsoft SQL, which is still terrible, but like it's much better than Oracle. Yeah, hi Wrote. I'm doing really well. Getting distracted, which is nice. I hate using ORMs just because I've never found them ever generating SQL queries that make sense. I always write my own. And even at work, we have our main system is entirely raw SQL, and it sounds awful, right? But the thing about it is that raw SQL isn't exposed to the user, right? So there's no injection possibility. That's all our backend system. Anything that we expose to a user, we typically do use ORM. Sadly, just because it is safer. Get less chance for injections. ORM is great for simple CRUD, which is why we use it for web services and stuff, and not for our serious like back-end heavy optimizations. I was writing a project, right? So one of the things I did recently in my final year of uni is we had to write like a app. So we wrote a web server, and my friends, let's put that kindly as an optional, because after they made this decision and made my life hell, it was maybe slightly different. I'm kidding, but the problem is they're like, oh, you know what we're gonna do, and the fact that this works every day is incredible. Anyway, what we're going to do is we're going to use Django and Python as our backend. And my god, is that thing slow. Like, this page loaded pretty fast, but that's because I spent like 8 hours trying to optimize this stuff. Like, the SQL queries alone to optimize this code is insane. Like, it's just so much work to optimize this stuff. And it was like simple select statements, it would just like completely screw up. And it was very hard to make it generate good SQL at all. And most of the time, you would like ask it to do something and it would just like not do it, but it wouldn't tell you it wouldn't do it. And so it would just be much slower. And so you would have to like get to output the raw SQL and be like, well, why didn't you apply this optimization? Even though I told you that it's unique, but you just ignored that, right? Anyway, this is actually a pretty cool app. It allows you to like have like RSS feeds and stuff, right? And you can link these RSS feeds and they automatically output in the app, as you can see here. And you can like, it's obviously a messaging app, and there's even stuff like videos and like PDFs and stuff. The formatting's a bit weird because I'm not a CSS genius. So I was like, you know what? I'm just going to chuck something together that somewhat looks right. And it works. You can even like have like XSS and stuff in it. You can see my face. There's like this stuff, and these are editable as well, and you can like share code and edit it with people and stuff. That was hell doing all that stuff. It even has like recommendation systems, so it pulls all your interests from like a bunch of things, like all the courses you've done and like all your Facebook interests and stuff, and we collect all this together, which is like very much like what companies do anyway, but at least we provide it to you as a service or your data collected, then it will kind of group you based on that, and you join groups with other people based on your interests. But it was really funny because we bound it for people when we kind of did it in like production, right? And for some reason, babysitting was an interest, and some of the automated interests it did based on babysitting were deeply concerning. Based on like random Facebook people. So honestly, I feel like this should never be released to the public purely based on some of those things. They were very much. I looked at them and was like, we are never releasing this. Um, so let's hope not. These are for the back end, like Node.js. Yeah, I don't know. I hate PHP, man. Yeah, PHP is interesting. Boolean and Boolean equal. Screw that, we're going to call it logical. Though in saying that, we had an automated name generator, and the automated name generator generates some like really, like you would think, oh, you're just chucking random, basically you're just chucking like random, well, not symbols, what do you call it? Not verbs. The description words. Adjectives. I can't believe I forgot what adjectives were. You're chucking random adjectives in front of words and combining them with like, you know, buts and ands and stuff, and it actually generated things that like made sense. Like one of them was like, I think it said like, oh, let me open up because these were great. I'll say some of them anyway. Not related to program question. Do you always check if Snake didn't hide inside your toilet? Maybe. Honestly, the funny thing about that is I actually have to. We're near my parents' place because we live near the bush. Near my place, which is like up in the city, I do not because it's in the city. And if a snake climbs like 20, floors, it deserves to kill me. I've accepted death at that point. But up here, there's spiders and snakes. I've killed like 2 or 3 snakes in my life. Like this is a common occurrence that does happen. You'll just like walk out in the garden and there'll just be like a snake, and you just have to like deal with it. Typically not kill it. Only depends. Okay, let me find these funny names. Yeah, okay, here we go. Long word games and late painting was one, which was pretty decent. Strange, ceaseless, Sim City was another, which is like, these are like, funnily enough, like possible names. Tearful, needless jokes. It's like completely random. I don't know, man. It was great. Average Abhorrent Inception, which is based upon the movie, I think. I don't know, man. It was interesting. It was a project to do. We did it in like 6 weeks, which is a lot of time to do code. I wrote like so many lines of code. I may not seem particularly fast based purely on this, but that's because I'm distracted. Which is the main reason I do stuff like this, is because being like on all the time is not really fun. Now these can be basically any expression whatsoever. So right now we'll only have operational expressions being our ops. Oh, I need to do boxes. That's fair. Yeah, that's fair. I'm happy doing box here. Did they do the new box syntax? At one point they were going to do like a new box syntax, but didn't they? I don't remember what it was. I just remember there being potentially a new way of defining it. I am on stable. I don't like writing on nightly. It's on nightly. There we go. Yeah. It was on nightly like 4 years ago. The one annoying thing that still annoys me to this day is the fact that I can't combine let statements and if conditions. Like, it's just such a simple feature that is just so annoyingly missing. And it means I have to write some pretty like random code just to do it. It's just like, why can't you just let me chuck an if condition with like some kind of sum? I know, also nightly. But it doesn't work that well on nightly. There's a bunch of bugs on nightly for it. Apparently it's going to be fixed by the end of Q3 this year, which is a fine, but like, my god, it was open in 2018. Yeah. Um, it's the one rough edge of Rust that annoys me. The rest of it's fine. Operational expression has a series of arguments, and these are going to be vectors, so that we get that indirection, which actually means this can just be a direct expression now. Actually, yeah, let's not go crazy at that. So this is just basically just, I'm flattening it out into a series of arguments with a single operator, which kind of just makes like unary and stuff, it will just be a single argument where the rest will be multiple. But the reason why it makes it convenient is because you're kind of unifying everything under like one banner for your expressions. And even like your indexing operator is just going to be an operator that acts on an object. So it means that you're able to make this separation. It's kind of weird. I don't know. I just like it. It just makes the code really clean when you get to parsing. And when you get to like handling and dealing with it anyway, you have to check the type of these things anyway, right? So it's much more convenient just to match, oh, if any of these operators do this, right, then it is to do otherwise. And precedence does not matter after parsing. After parsing, you don't care the kind of precedence order of the tree. Like, it doesn't matter. It's not something that matters because you're already going to ignore half of precedence anyway, because if you do something like this, right, you're going to grab this and remove these outer parentheses anyway and already chuck into an op expression. Like, this already happens in every compiler, right? And so already you lose that context of that precedence. So I don't think it matters to preserve it. I don't know, maybe we'll go back. I think a few compilers do this. I don't think Rust does this though. Not from memory. Okay, are we done? Yeah, I think so. Do you know why Java developers wear glasses? I do not know why Java developers. Because they can't see C sharp? Oh, yeah. I just, like, the joke in my head. I should have just said it out loud rather than trying to read it. I thought you were just like, yeah, okay, anyway. C sharp is so much better than Java. My god, love it. I used to teach a Java course. I still occasionally do at the uni. And the basic gist of it was Java sucks, but you need to learn it. And so most of the lessons were like, let's look at why Java can't implement arrays properly. And then you look for it. Or why generics are weird in Java and stuff like that. And most of the excuses are because the developers were lazy and didn't feel like doing it. Expressions, which is just going to be a vector of expressions. Now we are kind of leaving this a bit open because I think it's fine. Field is never read. Sure. Okay, this should be public. Okay, am I happy enough to continue? Yes, I am. Let's go. Let's write our parser. CIL. Is that the... What language is CIL? Is that the C# one? I thought the C# one was... Yeah, COR. That's the one I was remembering. I was remembering COR, not CIL. CIL. Yeah, I do wonder why that is one. Oh, but there can't be. The problem is I think Java loses too much context. Java bytecode is very simple. Yeah. So I know what the, I remember what the COR was. It's just don't remember what the CIL is. CIL has a lot more context in its bytecode than Java does. So Java bytecode expressions is very simple. So for example, I had to write a bytecode expression for Java recently to make it emit Java bytecode. Like a lot of it is actually like completely context free, which is insane. Like when you want to load a reference, you just like ask it to like load a reference, and there's like no types. Yeah, they're both pretty similar. They're both stack machines, but there's no like types that's encoded in it. Most of the types are kind of like type IDs and stuff, and they don't really do much other than just doing virtual function calls. And so there's like, yeah, the CLR it always has pinning. which is the concept where you can grab a pointer and kind of pin it so that the garbage collector can't really move it. And that's really important for how it does some of its lower level stuff. Especially you can now also do it as well. And so the problem is that you can't really. I mean, I guess you probably could convert Java to it, but I feel like the problem is you'd have to guess the types too much. I think that's basically what it comes down to from memory, is that you lose the type context way too much, and so it becomes too hard to convert it. But you know what you could always do? You could always grab Java bytecode, convert it to LVM, and then convert the LVM to CIL, which does have conversions, if you really wanted to be crazy. I'm sure there exist people who do that. I'm just going to re-export this stuff because I'm a madman. This is not how you should do this stuff, but that's fine. No worries. Thank you, Compiler Addict. See you later. I'm probably going to finish up soon too, probably in the next little bit. Catch you next time. Okay, super. That's good, I'm happy with that. And then we're just going to define our parser. It's 4 p.m. right now. I mean, I've got to go marinate some lamb chops for tonight. I'm one of those people that cook really fancy meals whenever like they're cooking with other people, but when they're by themselves, they cook like absolute like nothing. They've become extremely lazy. Yeah. I love cooking big meals. I cooked this like really nice like soup last night, and it was like gravy at the end. You just chuck in a bunch of like, you actually chuck a bit of gravy powder as well, but you chuck like a bunch of flour in with the like all the it's got like beef basically. You just like slow cook beef, but you chuck like the flour in at the end, and it turns into like a gravy almost. So it's not really like soupy anymore, so like a stew, and it's just really nice. You know, it just has so much flavor in it. Cook and compile. Okay, what am I doing for this? I forgot. I need Alexa for this. Probably defined. Yeah, let's do this. Which means I'm gonna have to define. Yeah. Okay. Let me do this. Just define everything for that. Be lazy. And then I will define the bounds here. Some decent viewers now. That's nice. Yeah, I mean, at the end of the day, if you want to see more, you can always like follow as well, so you can see when I go live. Because my schedule may be a bit sporadic. I'll try to do Saturdays and maybe Sundays, but who knows? If you're enjoying this kind of vibe, I don't know. Unnecessary, sure. And we want to do a public function for new. Did I call it new here as well? I don't remember what I call these things. Yeah, I did. What am I doing? Okay, that's fine. I will need a lot more state for this though. Okay. I'm going to do this. Am I? The problem with this is that you can't just... There's like a slight kind of problem with doing it this way, where you bind the pass error like this, because you actually do want to pass multiple errors and like actually be able to process through multiple things at once. You can't just like stop, right? So the fact that you do actually want to be able to process through kind of multiple items, like let's say you run into an error, and then you run into an error, you want to like keep going, right? You don't just want to stop at that current line. And so the big problem with that is that returning a result is probably incorrect. You probably want to return a program, and then this program's like tagged with a series of errors, right? So I'm actually going to do what's called an error tag, which is like kind of the same idea as a result, but you basically grab a node and you tag it with a value rather than separating them up. Hey, Bruce, welcome. I started my career about 2 years ago being a front-end developer in lower-level programs. Yeah, so like what kind of languages in front-end? Are we talking about like React, JavaScript, that kind of vibe? I mean, the same thing, but yeah, framework first language. He's pro Java. No, don't learn Java. Honestly, run away from it. Don't listen to him. He's the he's the siren. He's singing sweet songs, but he'll just crash. No, but like the language you choose for lower level stuff is, yeah, TypeScript is amazing. It's really nice. I would say the biggest shift problem when you're going from front end development to back end development is not so much kind of the programs you're developing, but more kind of the focus, right? And so effectively with back end development, the language you choose becomes a much bigger kind of predictor on how you write your program. With front end stuff, they're pretty much all the same thing, right? Vue and React, there's differences, but the way you kind of approach the problems is similar, right? So with Vue, you have a template, right? And your template is basically like JSX, but there's a few differences. You can't really chuck functions there, so you put functions in your code segment, and stuff like that. So there's similarities in a lot of ways of how you like approach a view, or like a page, rather. With backend, the way you approach every program is different, right? So here, I'm having to define enums and structs and doing implementations for that. Like the code looks very visually distinct between them, right? And so typically the language you choose kind of matters a bit more because you're going to be sticking with that for a bit longer. So I'd probably say C# is a great way to begin. Like learn a language like C#, which is a nice transition point because you don't really handle pointers yet. You're not going to deal with pointers. You're not going to deal with anything that's too crazy around references. And all of the semantics of like, for example, in React and TypeScript and stuff, if I pass an array into a function, right, and I modify that array, you modify the reference of that array, right? You modify both versions. And it does look very similar. That is a good point. And so you kind of deal with the reference versus value thing already. So for example, if you pass like a number into a TypeScript function and you modify that number, you're not modifying my version of that number, right? It's like a copy, right? It's called what's a value, right? Whereas if I pass an array or an object and you modify that, you're modifying both versions. I'm passing that object by reference, right? And so you really already deal with that semantics already. So when you transition to, C#, you kind of get those similar semantics. You don't really have to worry so much about it. So I would say it's the easiest ways to kind of transition to something like that. And probably a web server. Like, web dev already, right? So if you go build a backend for a web server somewhere, learn how that works, you kind of already know how the process is kind of integrating already, right? And if you do things like, it depends, but most cases it's the similar semantics as C#. So if the value is an object, like an array or like a class, it will pass by reference. Else if it's like a primitive, it will pass by value. But that's not always true. You can create what's called structures, and structures are like objects that pass by value. And you can also create, you can also do a special keyword called a ref pass, and that lets you pass something by reference as well. So for example, I don't know. I don't remember how you start a blank function anymore. State class program. I think it's like this, but I think you need to give this special arguments. Who knows? I guess we'll see. All right. I'm probably not going to run it. Especially since apparently it doesn't like my platform. Doesn't really matter. But the idea would be, let's say you got like a function like this, right? A. And this takes an argument called int, right? Even if you modify x here, right, you're modifying the value of x, right? You're not modifying the underlying reference. And so if we translate this to C or Rust and those kind of much lower, I wouldn't really call them low level, right? They're lower. That's the kind of consideration. People are stupid. People gatekeep. So if anyone ever goes off you about calling it a low level language, just call them an asshole. There's no reason to really care. Like, at the end of the day, it doesn't matter. But it is technically a lower, not low, right? They're still high level languages. And so what you're looking at is you're looking at not a pointer pass. So like it's kind of like instead of me going and making a copy for you, like and going and writing that value down on a different piece of paper and giving you that new copy, I've gone and kind of told you where the paper is, right? And so you can go and find it and modify it, right? So if I had ref here, I'm saying this X is passed by reference. And whenever I call it, right, I have to actually pass it a reference. And so, for example, I could go like x equals 2. They don't have to be named the same thing either, right? They can be named whatever they want. And then I can go A, and I have to go pass A by reference, right? So this is going to pass this integer, this primitive by reference. And effectively, it's going to wrap it in a pointer, right? Which is very, very nice and very convenient. And there's also the concept of what's called an out. So the difference between out and a reference is an out doesn't take input, it only like outputs it. So a reference is, oh, someone followed. I heard the noise. Thank you, Versus. I don't know. Oh yeah, it's a cute raccoon. So he's so adorable. Anyway, then you have with an out reference, the idea is that you're outputting it. It's like another return value, right? So typically in most languages, you only have one return value. Some languages have multiple and that they're typically quite good for that. But if you only have one return value and you want to do a conditional, so for example, you want to say, hey, try to pass this, right? Try to pass this function, this integer, right? And if you can't pass the integer from this string, then return false and don't do anything. Otherwise, give me something. But how can you write this nicely, right? In most languages like for Java, it's a mess. It requires exceptions. It requires all this stuff, right? In JavaScript, it's basically does it equal undefined, right? Now, JavaScript is and TypeScript the same. They're pretty loosely typed. Even though TypeScript kind of gives you these type annotations, it's still pretty loose, right? You can make everything undefined and kind of like add or undefined to everything, right? C# is very strict. So I can't just return undefined here for my int or something like that, right? So the typical way this works is that you basically, do your work, whatever, and if it succeeds, you set x. So x is equal to whatever your pass value is, and you can return true, right? If it doesn't succeed, then you return false, and you can set x to the default value for x, right? Or for x's type, rather. And so that way you call it, and you would say like something like this: if try int pass of 1 out int my x, and then you can use my x here. And like that's so nice, right? It's really, really nice to kind of write this stuff. And so C# kind of introduces these concepts of pointers and stuff, but introduces it very slowly. You don't jump into the pool. You kind of start off in this, fairyland of, hey, we don't have to worry about that. It's the same thing as TypeScript and JavaScript and React and stuff. But then it becomes this. Yeah, Sugar and C# is a bit too much. It is definitely, I would say, too much. But because the problem is the Sugar is great, but there's some things that would be nice if they focused on more rather than just adding more sugar. But the Sugar does make it really nice to write code in. One of the examples I always like to give is, like whenever I'm doing courses and stuff, is to show code in two languages that are basically identical and to show how much nicer it is to write in one. And that's what we call like a productivity change, right? So TypeScript's actually really quite productive to write in. Once you have all your types and everything, you really it's really quite nice. You can just kind of write the code. Things like, for example, in TypeScript, being able to say, okay, if A is true, you can say A and then you can run some function, right? And this allows you to basically do a ternary condition, say like, hey, if this is true, run this, right? And that's actually quite convenient for productivity, even though it's a bit nefarious, right? You do the same kind of thing in C#, but using basically this OR, kind of this conditional operation, right? It's called ternary operation. Though it's less convenient, and you can't run anything, and it's a bit different, so on. So typically you end up just writing like this, right? Though it's not an expression anymore, right? But productivity in a language like Java doesn't really exist. It's very unproductive, right? So you'll be spending hours of work trying to like write something that's very functionally simple, right? Just because you don't have those sugar things that make writing code easier, it just makes writing code so much longer, right? Anyway, so write C# and maybe write web server. A really good resource to start would be EF Core C# with MVC. So if you Google something like this, what you'll probably find is a really nice way to start, and you can basically instantly jump into a web app. The one caution is if you value anything in life that is reasonable, don't do a UWP or whatever this is. There's whatever name they've decided, this WPF, whatever the name they decided this year. Don't build one of these, right? These are like the native applications that run in your box. These are like if you're writing like a UI application, you'll do something like this in Windows. It's just so much code to do anything. There's so much boilerplate right now. It's actually like kind of the opposite issue. C# is typically quite small, it's quite loosey-goosey. It's quite like flexible. It's very sugared, very little code. UWP and WPF is not. You're writing a ton of code basically to do anything, right? It's very, very different, and it's not very easy. So I really would refrain away from those. If you want to kind of write like a nice UI, I was saying, doing something like Unity, which uses C#, or even what's the other one? I keep thinking of Atlassian, but that's not it. It's like starts with X, C# UI. What's it called? Not WPF. Mono has a UI toolkit that's good as well. For iOS. Xamarin, that's it. Xamarin. So Xamarin is the other way. It's much, much, much less boilerplate. It's really, really nice. Yeah, Xamarin. Thank you, Ketcho. It's very, very nice. Xamarin is absolutely beautiful at writing user interfaces. In some ways, there's definitely parts of it that's not so good, but it's very nice. And yeah, if you're gonna write like an iOS app or an Android app, do it in like C# if you're gonna do it across multiple environments. Avalonia is very good as well. That's a good point. Avalonia. The problem I have with Avalonia is purely down to the fact that there's still quite a bit of boilerplate. And it's not as like it's probably about the same actually. It's probably about the same. It's probably not too bad. It's probably fine. There's really probably not much difference between it. There's not that much. It's still very nice to write in. Yeah, it's still very much fine. Avalonia is good. Yeah, it's fine. Xamarin's probably more documentation or more support for like newer people. But Avalonia is just as fine. Okay, we're creating a program. Oh, I want to do tag programs, don't I? Okay. So the way tagging works in this case, because the thing that we're doing here is that we're kind of keeping our parser pretty generic. And this is a little bit intentional, right? So we don't really want it so that it just prints everything to standard output every single time, because that's fine. But like if we want it, for example, Let's say we want to output errors to a JSON format so that it can show up in this file like this. These we often use language servers. We kind of want to use the same parser. And so to kind of have to like write a new parser just for our language service is a little bit ridiculous. And it have like this like error consumer that comes along and picks up the errors and consumes them. It's also a little bit, I don't know, I just don't like it so much. So instead what I'm going to do is I'm basically going to grab the errors and kind of almost like propagate the errors upwards, I think. And so that at the end you'll get two structures. You'll get like a structure of the objects and then a structure of errors that like tag to specific objects. So you actually get information rather than just a bunch of lines that says, okay, this line is wrong, this line is wrong. It like tells you what specific node is wrong. And then those nodes actually exist in your tree as like error nodes. It may make debugging some of this stuff easier. And I've never done it before, so it kind of sounds fun. So why not tag node? So the first thing actually before we do any of this is we do need a generic kind of AST node because we do want to tag nodes that are like AST. Now I do hate, yeah, using this way. I do hate inheritance typically in a lot of things. I much prefer composition, but in this case it's fine. If I remember how to do inheritance for ASTs, I remember that at some point it was actually not too bad. What was it? It was like Rust, inherit. Oh, do I need to define it as a trait? I don't mind. I can define it as a trait. Yeah, there's no structure inheritance. Sure, composition. Yeah, that's fine. I want traits. This is a trait. Yeah. That's fine. How do I use a trait? Oh, I just implement it for that? Sure, easy. Okay. Sometimes there's an easy way of implementing traits. You can just chuck like a hashtag on it. Do I have to define a macro to do that? I felt like I may. Rust trait implementate default. There we go. Yep, that's good. Yep. Here we go, this is what I want. Oh, but you still have to specify an empty. I was gonna do that, but I don't know. Sure, I'll define an empty implicit AST block for it. Like, I will have code in here. Like, for example, one of the things will be things like emitting and stuff. Like, I typically prefer to keep my ASTs actually pretty flat and have functions that operate on them rather than using visitor patterns. Just because it does end up making it nice. But I guess we will see. I'm not going to worry too much for now. Okay, parser. And then this tag node is going to tag on anything that's an AST node. I think I can't just chuck this here. How do I do? I think I got to do like that. Yes, and it's going to warn let's never use, but that's okay. I could also just like take the node in directly rather than doing that. Yeah, that makes sense. And so I just have like the AST node being here. Oh, okay, they're deprecated. So I gotta chuck the type in as part of this, which is really what it is. Okay, sure. Hell yeah, there we go. Expected trait found type parameter AST. Isn't this a trait? Oh, I just do it like that. Sure. Let's see if this works. Yeah, okay, it works. What structure foods am I missing? Expressions. Hell yeah, it works. Okay. And then I want to tag it with a series of errors. So I'm gonna right now make the presumption that there's only one error per node maximum. But who knows? There may be more. I mean, we could also have an error consumer that basically takes one of these tag nodes and you're going to output to the consumer. You're going to say, hey, this specific AST node has an error. And then the error consumer can kind of like handle the list rather than... Actually, I made you that. So rather than having these output tag nodes, basically the tag node is not something that you output. You still just output like the raw program. But if there's an error, it would output a tag node for that. That may just make it simpler, which is probably a little bit better. So then you're going to give us a consumer that's going to take this error consumer, which is going to basically be a function that's going to take in a tag node and return a nothing. I don't even know if I need to have the return type here. I feel like I do. I thought that's how you define function types. I have not written Rust for a very long time. Most of this is me learning it again. Let's see how it works. I don't want pointer types. Just like a function type is fine. Sure. This is what I want. Okay. Oh, I see. I'd probably do like a... Oh, I gotta do like a call once, don't I? A once function once, is what I actually want. Definitely not this stuff. This stuff is for like low level decals. I think I want to do like a function once, but that would, I think that presumes you can only call the function once. Yeah, so instead I want a function that be called multiple times. Is that just function? It may just be function. Oh, so it is just function, but I actually want to define the arguments as function. I presume I can do that, right? Let's see. Has arguments and should produce an output. This does not need to produce an output. It can just take in a series of arguments. It's just going to take in a tag node for a dynamic trait. Is that what I need? Use parenthetical notion instead. Okay, sure. Actually, I'll just take a box of AST. That may just be simpler. And then I think I've got to put parentheses around the whole thing, I think. Okay, let's look. Function, parentheses, notation. Shouldn't be this hard. Nope. I remember doing this very recently. I just don't remember the syntax. Rust take in function argument. Yeah, I want to take in a closure. That'd be fine. Yeah, this is what I want. Okay. So I did have the right concept originally. I did have the right concept originally. Okay. It probably doesn't have to be boxed actually. Okay, it does have to be boxed because we don't know the size compile time. That makes sense. Yes. And it's epi. Okay. Unused parameter. Awesome. And then we can track this on our error consumer. Let's give us a type actually. Jesus, why is this one fly is just being an asshole? Get away from me. I don't know. Just call it like error consumer. Hell yeah. So the point of this error consumer now is that we can send errors to it. So you know, if there's a problem for our program, we can just say, hey, self.error consumer, here you go. And guess what? The arguments are going to be basically just a program in this case, let's say. We have to create like a program within a box. And then this just needs expressions. Look at that. Probably box new. Okay. Use of unstable library. That's fun. Oh yeah, I have to create the tag node first. That's fair. Let's try doing that actually. So create the tag node. Missing structure fields. Let's see. So we give it an AST node, and this is program. And it needs expressions, so we'll just give it empty vector. What's a tuple? Okay, we can give you a tuple. We also need to give you an error, sure. Just pass error is probably enough. There's actually no errors here, so I'm just gonna say none, just for the sake of. I just wanted to make sure there's passes before we keep going. Okay, and then what's next? Core's being cranky. Ignore that. Yes. I just need to grab it in the heap. That's it. Hell yeah. Let's have a look at this. See if there's a workaround for our case. We could always require it to be a visitor, which isn't necessarily bad for like visitor patterns to be able to do this, right? So you grab your trait and then you simplify it down to a bunch of cores. And what that will do is that will remove this kind of annoyance. Maybe I won't do that. Maybe I won't do that. It may make more sense because then you kind of have a larger concept of what the like underlying AST actually is. You could also just make this an enum that represents all AST objects, right? Rather than having this kind of weird trait thing, saying, hey, operating specifically on this trait. Either's fine. Like, from most of the use case, you're mostly just going to be calling functions on this to say print this out or whatever, right? Like, go to this AST's location and stuff. It's like generic AST stuff that you don't really need the subclass for. Core function with trait. Oh my lord. No. No, don't do this. I don't want to do that. So, like, the problem here is that you're calling a function traits. I don't know. Like, I presume this is just having, like, traits inside, like, the function type. I'm sure there's a way we can get around it, which is kind of the point of this. Oh. Thank you, Rust. That would be a nice error to say. The problem was very clearly much that, for some bloody reason, it decided. Oh, you went, oh, okay. You know what's actually the problem is that you shouldn't be doing .core and it. You should actually just call the function point directly. Yeah, that's fun. Yeah, I don't know why I would want that. It's kind of weird, honestly. There's definitely a few rough points. It probably could have said, "Hey, are you meaning to instead just call the thing?" But that's okay. This is also very weird syntax, having to surround this. The reason why you have to surround it like this is because this could actually be a function within the class as well. So it has to like recognize whether or not you're talking about the field or the member. A little bit unusual, but that's fine. But this works. This will actually go off and call this function and say, hey, you know, there's a problem with this AST object, and here's the parse error, right? And if they want to know specifically what the AST object is, then we could parse type information and stuff like that, but it's fine. In most cases, it will be fine. I think we can add required traits to implement on the trait here. I think all we have to do is just do something like this, where we say, okay, every trait has to implement debug, for example. Like, I think that's the thing. Yeah, expected trait. I'm trying to find what the debug trait is, though. Rust debug trait. And so we can see things like, hey, you have to implement all these kind of traits, and so therefore you can use those traits. This is the trait. Okay, do I just have to like specify it manually? I do. And look, I have to implement this for each one. So there's a few other traits we'll probably require as well, but this is a good start. Debug, I think I also want... that's fine. What do I want? That's probably enough. You just need to know the debug of the type. It could be useful to have like slightly more specific ones, but I think this is fine. Let's not go crazy. Wait, what am I doing? One. It's getting reasonably late. I may start winding up now. Taking a bit of a chill for a night. This is basically structurally done. There isn't too much more I need to do here. Other than actually just calling the passing functions, which is really easy to write. So I think what we'll do is we'll probably end it here. So thank you everyone who came along. It's chilling out. If you feel free to follow and stuff like that if you want to. And you can see when I go live. It's a bit sporadic, but I mean to be fair, I've done the last day and this day, but both sequentially. So we'll see how it goes. And then if I do more, I'll probably do a bit more next week. Anyway, I'll see you.